Hello, everyone, and welcome to the NANDA Summit. Today, we're going to focus on the consumerization of Agentic Web. We have a packed program today. I'm Ramesh Raskar, professor at MIT. We'll have Peeyush Aggarwal from Deloitte sharing his thoughts. Then we'll have Nick Cooper from OpenAI. And then we will have Fatih Porikli from Qualcomm talking about Edge AI and how that's going to change the Agentic Web. We'll have Jessica Rosenworcel, the former head of FCC, and she has some interesting thoughts about how the evolution of telecom infrastructure has some lessons for how the evolution of Agentic Web is going to play out. Then we're going to have some amazing demos, amazing reference implementations, some new algorithms, some new papers from the NANDA team, especially about NANDA Index and so-called NANDA Picker that allows you to be a kind of a universal adapter for A2A, MCP, HTTP, NL-Web, and so on. So then we'll hear some papers that NANDA team is writing, especially we'll have two additional guests, John Zinke from Akamai and Joe Zhang from Cisco. And then we'll have two really rapid fire overviews of the current Agentic Web landscape from Ashish Bhatia and Rakesh Gohal. And then we'll have a whole hour afterwards at the end where we will learn from how Web3 community, who has been instrumental in thinking about decentralization of computing, what can we learn from this community? And today we had an RFP for proposal coming out from a Web3 community. So you'll hear a lot more about that. So NANDA is building a quilt in a post-AI world for the Agentic Web. And we want you to think about, billions, maybe trillions of AI agents on a road trip, kind of navigating, communicating, socializing, learning, earning, and transacting, sometimes on our behalf, but sometimes autonomously. In that world, I think it will be good to think about an analogy with, how the telecom ecosystem has moved. When we had landline phones, the phones were reachable, at the same exact location through wires. But as companies and big organizations started having switchboards and extension numbers, not everybody needed a phone number that listed in the white pages. Similarly, the new agent registries will have defederation, and you just need a front desk. So, all the agents inside a company don't have to reveal who they are. And then finally, as phones move to mobile phones, the endpoints are switching all the time. Today, I'm here in Boston. Tomorrow, I could be in Singapore. And, your phone should be able to call my phone no matter where we are. So the fact that we have to continuously change the endpoints, brings in new challenges. So I think the Agentic Web is more like the mobile phones, where things are changing very rapidly, as opposed to the landline phones, which is how the websites work today with fixed endpoints. And that's why the roadmap for Project NANDA is very long, thinking about privacy, machine learning, knowledge pricing, and so on. But in the very short term, we are focusing on the index, a federation of registries. And we'll talk more about that. And the way we are working on all these efforts is by bringing in many scientists, many researchers, many engineers, many policy folks from many companies, many organizations, many universities, and so on. If you're interested in writing papers with us, working on intellectual conversations about this, very nuanced, we meet 2 times a week. We'll give you some instructions in about 1 hour for that. And also to make this as neutral as possible, even the index, the NANDA Index, is hosted at 15 different universities across the world. And as I said, starting in about 40 minutes, we'll be showing you, all the reference implementation, the code, walk you through the website, and so on. I really want to thank, all the organizations that are funding us, partnering with us, co-authoring with us, and we welcome all of you to join that as well. Later on, we'll show you how A2A, HTTP, MCP, NL-Web all can be thought of as an extension of an agent. And as I said, the roadmap for Project NANDA, building kind of a Agentic Web, is thinking about all these components that you see on the screen. Of course, the stuff on the right, which is agent creation, how to ingest data, how to use compute is sufficiently well understood. But if you look at the left side, especially things in orange, foundation, trust, communication, transaction, are the things that will be the infrastructure for the agentic web. In addition to that, there are marketplaces and applications. So we think there are about 7 choke points that we need to solve. And also we need to make them that are open and vibrant. We're hearing a lot about communication, which is through A2A and MCP. These are very important components, nevertheless, a very tiny piece of the big puzzle. So over the next several years, here at MIT and at Project NANDA, we're working with many partners to build out this roadmap. And as I said earlier, unlike landlines, we want to think like mobile phones. Websites are more like landlines, and agents are more like mobile phones. They have edge ML, they're edge AI, they're mobile, they're bidirectional, and so on. So this brings in all kinds of issues. And so a registry, somebody could think about registry like MCP registry is thinking about, just a centralized registry that lists all the different agents and all the different tools, but we don't think that's scalable. The other approach would be some kind of a decentralized solution, but it has the issue that it could get re-centralized. And finally, we think a hybrid solution, which is the NANDA quilt, is a good compromise between the two. So NANDA index is a lightweight central index that routes requests from relevant local registries, avoiding full centralization. Nevertheless, every organization can host their own agent registries, in a decentralized way. So for us, agents is every one of these things: compute, data, tools, MCP servers, NL web servers. For all of these, we think them as just agents, and we want to create a universal access, as you will see in about 40 minutes from now. So with that, let me invite Peeyush Aggarwal from Deloitte to share some of his thoughts. And Peeyush, while you're coming up on video, I would love to show something. So Peeyush, you can come on video here. So while Peeyush is coming up, I would encourage you to go to join39.org, and create your own agent in about 30 seconds. Just create your profile, and I already signed in, so I already have my agent that's created here. I have my agent facts card, I have my conversation history, and you can go to any of these agents and talk to them. So we have Dr. Kiran, for example, here, and I can have a chat with Dr. Kiran, like, what do you do? For example, right? And it'll allow me to see, what, who Dr. Kiran is and what is your expertise, and so on. So feel free to create your agent. We'll post this link in the chat for you. Peeyush. All right, Peeyush, I think we don't hear you, we don't see you. All right, looks like we're running into some trouble. So I'll request Peeyush to start his video and get started.
Yeah, thank you very much. Sorry, apologies. It took some time.
Go ahead, Peeyush.
Hey, how are you this morning?
All right. Any quick thoughts or comments before we hand it over to Nick Cooper from OpenAI?
Thanks a lot. Much appreciated, Ramesh. I think it's an exciting time. I think if you look upon, go back in time to 1995 when the web browser was launched, and the internet took its shape, right? It was about all static web pages, information and data sharing between different organizations and humans and machines. And I think as we took through the journey over the last 25 years from digitization, I think we have come to a point where those pages have become dynamic, but they are all request and response, right? And as enterprises start to deploy this technology, build those agents, an interesting part which I am excited about is how will the agentic architecture take shape from a consumer standpoint, but also from an enterprise standpoint. And for this consumer and enterprise agents to talk to each other, it requires, trust. It requires exchange of value. between in a B2B environment and a B2C environment. And as we saw in the internet age, that we went from intranet of web pages to internet of web pages, and then to a complete economy where we basically have we are using internet for social media advertising and other usage that it was not designed for. It was designed to share research in the initial days when it was conceptualized. We are in the same era now with agents now being deployed. Agents are being deployed inside the enterprise. And I think we need an open architecture, an open standard, an open framework that allows these agents to talk to each other. And I think it's that open framework that Ramesh, you and your team are building upon, which is what puts the standards out there that requires us to engage in a conversation. What is critical for me is to be able to discover and search those agents, but not only discover and search, but create and collaborate to create that trusted relationship between two agents, whether it's a consumer to an enterprise, or enterprise to an enterprise, or enterprise to a consumer, and it has to react and respond to in an asynchronous way, both ways. And it is not about like we do on web pages, which is a request and response. It needs to be able to react to inputs and outputs from each of those engagements. I think if I look forward, I think there is quite a bit happening in this infrastructure. And what I see is that as organizations start to realize the value of this, they will think about agentic AI almost, if they think about this as a replacement of the previous RPA regime, you basically will fail, because what will happen is the current architectures and the data that is in the enterprises is very rigid. And these agents that are smart will have to basically have. So hence, in our opinion, it is about reimagining the process, reimagining the enterprise, and obviously in the future, reimagining the industry. And what I mean by process reimagination is the form factor has changed fundamentally of how you take the input, and hence process reimagination will be a key factor as we look into it. The economic implications of this interaction will be fundamental, right? As we go through it, you will see, the current advertising revenues that you see in a lot of organization, or the social media engagement that happens, will start to move towards an economic model, which is basically where there is zero switching cost. There is disintermediation or shift in power between different agentic architecture. You can unbundle and rebundle your services. From being reactive, you will have to be proactive from the agentic architecture perspective. So it's a fundamental shift in how enterprises and consumers will think about using this technology. And I think as we look into it, you will start to see dynamic pricing and hyper personalization in you leveraging some of this. And hence, I personally believe as we look into the future, this is a fundamental shift in not only how we think about the agent-to-agent communication, Ramesh. It is also about building the future economy that will enable the human-to-machine interaction in a trusted and in a way that basically generates value for both the ecosystem and for the consumers itself. I leave it there. I think this is a broad topic. There is quite to talk about in terms of how does the enterprises evolve, and we'll be happy to cover that at a future date.
Excellent. Thank you, Peeyush. I think you said something very important, which is as we start thinking about moving away from purely enterprise agents, the enterprises need to start thinking about what does it mean when every consumer has their own agent. This is a very important aspect. I'm going to request Nick Cooper to come on up.
Hello,
right.
Hello, Ramesh. Hello, everyone.
Welcome, Nick.
I'm going to be relying on you, Ramesh, to drive slides, I believe. But
absolutely.
So next slide. So everyone, this is a sort of variation of a talk I've given earlier on essentially Composable Model Context Protocol, and how we start to see that even the tools we have today are leading to emergent properties that line up with this future agentic web that everyone here is quite excited about. Next slide, please. So I'm firstly going to talk about MCP, just very loosely as to what it does, and then how we build these emergent properties forward and forward and forward until we truly get a sense of agency. So next slide, please. So this is just a quick intro for anyone who's not intimately familiar, but MCP, or the Model Context Protocol, is essentially answering the problem that our models and systems all need to interact with external tools and data. And MCP is one protocol that attempts to meet this need, providing structured JSON contracts for tools and data, amongst other functions. And it's having a bit of a renaissance in popularity right now. Next slide, please. So the way I think about it is a sort of a layered stack, which is ultimately starting from the left, you have a host, which is like some application or potentially agent or something trying to achieve a given outcome. That host uses a client. That client talks to a server. That server exposes context. And this is very standard and sort of the layer diagram of how people think MCP works today. And it's very literally in the name. Like it's MCP, it's the Model Context Protocol. So if we're going from left to right, we have model, then the protocol to speak to the context at the end. So next slide, please. One thing, though, that we've been exploring a bunch is what happens if instead of speaking to context, we actually put MCP servers in front of MCP servers? As I think the relatively popular idiom goes, it's turtles all the way down. So what if we do MCP on top of MCP? Next slide, please. So the first example of this is transformation. Transformation is the case where MCP servers can provide context to the model as they do today, but they can also transform context. For instance, context out from an MCP server could be transformed to generate a new piece of context for a different MCP server. Next slide, please. An example of this is we have some sort of raw MCP followed by a user MCP. So a server could be annotating upstream context, auto approval. It could be including a human in the loop. It could have created opportunities for injecting audit logging or further understanding. It can rename or filter existing tools. These are examples where you can build a proxy server that expresses a single policy agnostic to the underlying implementation. For example, we could have an MCP server that indicates is an underlying action approved or not. Next slide, please. For a more advanced version, oh, my formatting apparently got. Let me see if I can fix this in one hit.
It won't because I'll have to refresh the.
Yeah. Okay. Go ahead. Well, so I'll go on. Apologies for that. Another more complicated example is actually what I'm calling projection, which is there are canonical standard examples of MCP servers that present an underlying file system. One could imagine layering on top of that an MCP server that vectorizes this file system, as in it provides embeddings for every file. And then on top of that, you can have an MCP server that, given embeddings, knows how to do some sort of vice like KNN search or index. So these are distinct layers, and very importantly, each one is very generic. Like the search tool MCP server only cares that its input has embeddings. It doesn't care that there are underlying files. The embedding server only cares that there are files, and it doesn't need to provide search. So you can isolate the composition and functionality you need. Next slide, please. I think we're going to have this problem with a few diagrams. This is a bit of a stretch definition, but it's a useful idiom. But like this composition allowing to distinct responsibilities allows us to build up a more complex component as part of the simpler one. As many may be familiar from like introduction to computer science or software engineering or programming, there's quite often this idea of object-oriented composition, where we have like an engine as part of a car. And this allows you to build domain-specific MCPs that only expose some higher level interface or functionality. Next slide, please. All my examples have been starting with this idea of you taking one input and producing one output, like we went from files to RAG. Composition is obviously you might need more than one component, like a car clearly has more than just the engine. Next slide, please. For a very fixed example that is familiar for a lot of workflow systems we have today, such as GitHub Actions or BuildKite or any other build system, we have this concept of a YAML workflow that does very fixed deterministic actions of how to orchestrate more complicated steps. we can imagine the same thing for MCPs. Like, what if an MCP server had a YAML workflow of how to orchestrate other MCP servers? This allows us to have a domain focused on orchestration itself and expose higher level abstractions there. But the later components can provide reference to the original resources. Like, we can have each one be very focused and have this strict rule on tool chaining. Next slide, please. Where that was fanning in, like building complex functionality into an orchestrated whole, this is fanning out, which is we need lookups, we need discovery, we need to find MCP servers, but we've been given this abstract API of how to search and understand resources in context. So let's use it. This is actually an active conversation that we've had with some of the MCP steering committee around this idea of search over MCP servers itself being an MCP server. Next slide, please. Apologies again on the diagrams. Once we have the idea of sort of composition and federation, we can then merge results. So this diagram is a bit messy, but once we have two servers that expose a similar shape of tool interface, we can merge them together. Like, if you have two different search results, we can now achieve federated search by layering an MCP server whose sole responsibility is aggregating and perhaps meaningfully re-ranking results from underlying simpler MCP servers. Next slide, please. This leads to apparently a very complicated diagram. Oh, are you redoing the? Yay, okay.
Is it 30?
Yeah,
38, right?
Yes, that is it. Thank you very much for that. Bringing this all together, we end up with, like, we can do orchestration, we can do transformation, we can merge all these things together, we can start to build a complicated graph, and we have servers that do nothing other than orchestrate other servers, and we've created this whole fleet of interesting MCP servers. Next slide, please. But very obviously, as like is hopefully evident to many, as soon as I started to create this complex network and graph of connected simple MCP servers, we then have, of course, a very interesting opportunity to add a model. By adding an LLM to basically any of the earlier examples, we transform them into things that start to feel more agentic. Next slide, please. Like, our earlier policy-based server can now be based on probabilities, or it can be based on intelligent. It can make policy decisions and annotation of an underlying MCP server. One particularly interesting one to me on this is automatic fault detection and suspicious activity detection can be layered as an MCP server who has that as its sole responsibility. Next slide, please. In the same sense, intelligent delegation. MCP servers can tell you how to find the most appropriate MCP server for your own task. And then next slide, please. Finally, in federation, earlier I glossed over this, but like, when you have more than one search tool and you want to merge the results, it's actually an extremely difficult problem. Federated search tools don't necessarily have a uniform measure of quality or scoring or ranking. They might not even have ideally the same representations of results. LLMs allow us to bridge this. We can build smart merging that's context aware. We can build truly intelligent, generic federated tools. Next slide, please. Now, all of this is just very direct applications of MCP servers that we see today. Like, this is examples that we've seen in the wild. Like, there are in fact many companies that offer MCP registries, and some of them even are intelligent and include models to do search and discovery. What are other things in the specification that we from OpenAI are excited to see moving forward? Next slide, please. One, of course, is when as soon as you talk about any complex process, a complex process can be slow, even without a model. Where there's a tool call that we treat typically like an RPC, it can be potentially streaming. It tends to convey an expectation of a short time horizon. This just isn't realistic in many cases. We need to figure out ways to share immediate state and indicate progress for tasks that could take minutes, hours, days, or even an indefinite time. Next slide, please. As soon as you make a tool context last forever, you then immediately need some form of elicitation or steering. This is actually a new feature that's in the draft MCP specification, but the intention is for a tool that is long running, it needs to provide a way to indicate to its caller, like typically a human or user, or potentially, as I've said, another MCP server, that more input is required, more detail or steering or authentication or approval. This helps ensure that the long-waited response is still valuable. Next slide, please. Discovery becomes a problem immediately. So I've defined this utility of a complex web of MCP servers, but I didn't really I sort of glossed over. How do you discover them? How do you identify them? What is the name? We want to build complex graphs of these things. We need to work together with others to federate across many potential providers. And to do this, we need robust concepts of identity and as well as a way to explore the space of all identities. Next slide, please. There are a lot of ways to solve these problems. The variability is exciting. We continue to discuss with other groups and aim for standards when compelling configurations emerge or encourage even more future exploration. From our standpoint, there's a lot of interesting opportunity with these simple specifications composed together, and we're excited to continue to explore this as well as refine what becomes an agentic web. Next slide, please. Now, the magic word is always agent or agentic. I've so far until just then avoided basically mentioning it in this entire presentation. Is what I described agentic? It's an open question to me. Next slide, please. I do think that we begin to see in complex composition signs of agency or agentic behavior, but it's not clear that we've done anything better than build smarter tools. The example that I've often given is in database technology, most databases consist of a query planner followed by a query execution engine. A query planner is usually based on heuristics or math or some human intuition. It's a very natural place that you could imagine installing an LLM to do abstract query planning, perhaps in a more efficient fashion. But do I make a database agentic by making it have a model-based query planner? I think it's clear to me that that is not the case. Like, intelligence of a query planner does not inherently make it agentic. But if adding a model is not enough by itself, what is? Next slide, please. And this is where projects like NANDA are exciting, because the complex composition introduces issues of routing, discovery, identity, authentication, all of which are parts of the Quilt proposal and implementations that we just heard about. And we continue to explore, discuss, and expand with others to find some stable emergent solution here. I think in doing so, we're going to go to refine and define what actually makes agency and agentic things better than just smarter tools. And next slide, please. With that, I actually reach the ending and an opportunity perhaps to respond to some Q&A.
Yeah, thank you. Thank you. That was amazing, Nick. I know you really have thought about this in so many ways. There's some questions emerging. I'll take a couple of them, and you're welcome to kind of answer them on your own in text.
Yep.
I guess the very first one I would like to ask is, as you start, layering MCP servers, whether they have agentic behavior or not, is kind of creating, multiple points of failure. And also, as you start adding more and more intelligent layers, the delegation is going to be like, the game of telephone, where by the time you, talk to the last person, they heard something entirely different. So how do you deal with the fact that in some cases, it would rather be better to have rule-based or API-based solutions. In other cases, it'll be good to have some LLMs that are effectively creating a recipe of those APIs. How do you see that playing, and what do you see the role of index or a registry in that?
So I'll start with the last question because I actually think it's a bit easier. But a registry or index for me is about discovery and identity. And part of discovery and identity is also trust. Any registry implicitly purports to represent trust in its contents. So this is an opportunity for like community-based validation, like star rating, comments, feedback, this sort of thing, or perhaps some direct-based like attribution indicating the registry owner trusts the contents of this registry. So trust and identity are very paramount in this world because there's many, many examples of misplaced trust on the internet historically. As for the provenance and building like delegated workflows or control systems, I don't think it's exclusively one or the other. As I said before, like I can model a YAML fixed space, perhaps like more old world orchestration workflow as a fixed MCP expression, or I can ask an LLM to do it, and I can do everything in between. Like I could imagine using a model to write a fixed workflow, a YAML. I could imagine using a model to validate a human written YAML. All these permutations exist, but I think they can be encapsulated in MCP servers or similar abstractions that are responsible for orchestration. They don't need to be like a protocol level thing, but rather an emergent behavior and allow flexible composition to allow you to solve workflow problems in many different ways.
Yeah, that's fascinating. Separately, in about 40 minutes or in about 30 minutes now, you will see a universal adapter that's built by the extended NANDA team. I would love to get your thoughts on, what does it mean to, I mean, as amazing as MCP is, as you described earlier, it can only do so much, and doesn't really add intelligence to what's happening with the APIs, but adds intelligence kind of as a preprocessor. So how do you see this juxtaposition of, LLMs and HTTP and different protocols and adapters? Are we just making our life more difficult? And would we rather have, very curated experience built by one company? Like, what's the benefit of having this, very diffusion of different solutions that we have to kind of all do plumbing around it versus something that would be delivered by a single company?
Well, certainly our interest is very much focused on an open ecosystem. I think part of it is because being on the cutting edge of all these product developments, there's always implicit uncertainty. Like everything we build searches to find product market fit or utility or be useful to someone in some context. And so we need to build a variety of solutions. And part of achieving this variety is really enabling an ecosystem to thrive. Like MCP is a popular answer today, and we embrace it in a bunch of our products. It may not be the most popular answer a year from now. There may be new ones. There are many alternative examples today. Also, even parts of MCP are very similar to earlier standards, such as OpenAPI.
Right.
So it's unclear. I do think there is some degree of inherent confusion with this space of exploration, but I think it's premature for us to try to overly standardize it because we really need this flexibility to find out how we can apply LLMs and these tools.
Fantastic. Thank you, Nick. Thank you for joining us. So much to think about, because I think 6 months ago when folks were thinking about adding more context, we thought maybe we'll be adding context in traditional ways. But the fact that MCP allows you to use APIs, and now you're thinking about creating this graph of resources, tools, APIs, and LLMs is going to be very fascinating. Thank you. And you're welcome to stay on and answer some of the questions that are showing up in the chat and also in the Q&A section.
Yeah, I'll get to the questions in the chat asynchronously as you continue.
Sounds good. So with that, let me invite Fatih Porikli. Fatih is a longtime colleague, a longtime friend. We actually used to work together about 20 years ago. Since then, Fatih has gone on to work on some amazing projects, leading some very important innovation teams at Qualcomm. And now he's leading an effort to really think about agents and agentic AI. So Fatih, take it away.
Thank you so much, Ramesh. I'm very pleased and excited to be here. Thanks for having me. We can go to the next slide. There is a video that maybe I would love, if possible, to.
Yeah, I'll do that.
People. There is audio also in that video.
Hopefully, please. Oh, I don't have access.
Okay. It says,
We'll have to move ahead without video. As I said, we can do AI, but getting AV is not going to be easy.
Why we are here. Yeah, I can talk about the video though in this slide. So
Yeah, go
next video was showing an example of agentic AI, how it is being useful for our daily lives. So what it was showing that, okay, there is this test. You can ask very complex queries. For instance, can you remind me when my sister will arrive, then it will, kind of go back to SMS and all the emails and everything, personal database. It will give that information and then show it on your kind of phone on the edge device. And that interface could be text-based or audio-based, very natural. And then, like you are interacting with your AI assistant or assistant, kind of, Greg, can you also remind me what my sister wants to see while in San Diego? So I'm in San Diego, that's why my sister is visiting in San Diego. And then, this question is a bit interesting because now we are asking the assistant to remind something that we had maybe a discussion, a conversation we had in the past. It could be also our SMS messages, it could be our emails, anything that we can, kind of discuss, interact with, they are all captured. I mean, we have a solution that all captures and put them into a personal database, and the demo was showing that. And then there is this retrieval augmented generation, which would look at the history and then, kind of then retrieve the information. Then in the follow-up question, it was going to be, oh, okay, my sister, kind of wants to buy some certain type of gift or wants to have a coffee together at a special place. Then give me the address of it. So it will go through back again to another agent, maybe is done around on the other hand, and then it will get the map. So this demo was a multi-turn, task-oriented, context-aware, natural and personalized demo through natural human dialogues, and it is interactive also through the voice interface, speech interface, but it could be from to anything, and then it can access multiple data sources for multiple functionality through in the map that available. It can go and look at what is available to complete the query. And we have, of course, by the way,
Fadi, your voice is very weak. If you can get closer
my
to
voice is very weak. What should I do?
if you can get closer, that'll be great. Or
microphone. Maybe my microphone setup. Let me see.
that's already better. That's already better.
It's better.
Yes.
I am.
What about now? Is it better?
Super good, super good.
Because that was my laptop's microphone. You see, still, we need agents to discover this. Thank you so much. Yeah, sorry about that, because that part was very exciting to us. Agentic is very excited, and we are very interested in agentic. I personally believe that that is the next frontier. But getting agentic AI running on cloud, on edge, it's not an easy task, not an easy kind of adventure, and that's why I'm very happy to be here, a part of the NANDA, and thank you so much, Ramesh, also about that. For that purpose, we also have this AI orchestrator, Qualcomm, and soon will be available for everyone. It's going to do many things on the edge device that some of it you see, kind of things about API calls, and then the databases and everything. And it's going to provide very kind of enhanced privacy, very reliable solutions, and you can personalize such solutions, which are very important, in addition to being cost effective. And you don't need maybe cloud for many things to make such decision. So this is Orchestrator is our full stack AI optimization supported by our AI optimization solutions tool. And then, we believe as Qualcomm, AI is the new UI, and then maybe the Agentic Web is the new web. We can go to the next slide. And Nick also mentioned a little bit, and I just want to add some more flavor. And some of the questions on the chat, they were asking about real use cases. What are those? And what is agentic? Kind of very briefly, maybe I will say that such agentic systems are the solutions that can make autonomous decisions and take actions based on the environment, and everything is required, the goals and the query. And as you see, on one end, there is a smart oracle human, and then it is also observed. Then there is this critical question: where are we going to run it? Are we going to run it on the cloud or on the edge? Then there is all like these pink boxes, all decision AI related solutions where they fit in, from intent classification to planner to verifier to kind of interacting through UI browser to tool calling, and then it goes to the web or robots or other people, and then we need to reflect whether it makes sense or not, then adapt. That's where personalization comes. Let's go to the next slide. Again, I'm trying to give 360. There are different levels of personalization, of course. For instance, it could be simple understanding the user preference. And for that, we need to build a personal memory database. And that database, is going to share something with the web. And then there is also maybe next level would be understanding user content. And that content is going to be also not only on device, because I'm holding my phone, but then maybe my emails are somewhere else, right? So there needs to be something standard that is talking to some other agent somewhere else. So we need this agentic web interfaces standardization to enable that part also. And then another one is understanding what I am doing, maybe my driving behavior, or how I'm kind of running through my day. And then there are things that maybe such assistance needs to predict, understand my intent, and maybe proactively provide some feedback. We can go to the next slide. And also there is this aspect of, kind of where such things are executed. We started as LLMs, they are all digital, right? And then there are virtual assistants guiding AI agents, for instance, tool calling. We are maybe changing the way that that LLM is interacting through some visuals. But then there is passive multimodal kind of models also now available. They can see outside or hear outside, or there are additional modality, and then based on that they make a decision. And then there are situated multimodal solutions. For instance, maybe there is, like in this webinars, the data is streaming, and then maybe the agent is looking directly into this and then making decision automatically. And the next level would be robots, autonomous vehicles, specialized robots, or kind of embodied AI. All of it, as you see that from the digital realm to physical domain, there are things not only on device but outside the device, and that interface, hopefully with better agentic web solutions, would be enabled. Let's go to the next slide, Ramesh. And here is what we are offering, and this is going to be available very soon, in a couple of months, and anyone can use it. It is an SDK, it's an orchestrator. As you see, there are different components, from local data to kind of there is this under orchestrator tools, from intent classification to planner to database management, RAG to guardrails. Also, you want to make sure that such an agent wouldn't start automatically sending emails to everyone on your kind of email list, on your contact book, and maybe questionable content also, or kind of you don't want to bombard them. But agentic AI systems can do that. But when we give them bodies, like a robotic application, it would be even more critical. And then there is everything, zillions of applications, zillions of websites. There are many different APIs. So we need to access it, but kind of it's a big challenge, as maybe NANDA is trying to provide that part, very critical part. And those are maybe through adapters that are helping such models to adapt themselves. I mean, this is maybe low-level AI related, AI research related kind of challenge. Then, kind of there are these models, we are talking about agents, but what are those agents actually, how they are realized? Are there LLMs or some other things, kind of they need to be maybe customized. At the end, they are going to talk to each other, but are they talking the same language also? This is one of the things that we are thinking. Do they need to talk English, for instance, or is there any kind of neuro-symbolic or API-based languages like HTML or maybe something else, kind of will make better sense for them to talk? Or, are we going to treat them as human beings that then, kind of make everything through English? And honestly, some of the planners, they do like that, but there are code generation models, they are switching to neuro-symbolic representations. And you see, this is running on the edge. But then, of course, our orchestrator also has a part that is for the cloud, but then the rest is Agentic Web. And I can imagine in very soon, maybe in a couple of months, I don't think in a couple of years we have to wait that long, but there will be a lot of agents everywhere on all, kind of service providers or internet services like map services, booking services, everything you can imagine. But the challenge is how they are going to accomplish the common goal together and, kind of wouldn't create a lot of headache for the user. We are trying to make everything better for the user, for myself, right? I don't need to keep on answering many questions, but they will autonomously solve the problems and then, kind of most importantly, communicate with each other, understand each other, then solve the problems, then, provide simple things back to the user. This is almost my last slide, Ramesh, and if I have a minute, do I have a minute or?
Yeah, go ahead. Yeah, go ahead.
Yeah, and about use cases, it is coming more and more. I mean, what are these use cases? I don't want to be on the, high level, too high level and not relating to the use cases because some of the questions, again like asking that on the chat. One use case is automating app calling and function calling, for instance, meeting scheduling, project planning, research assistant, shopping. For instance, trip example could be, please help me to plan a trip from San Diego to Austin, spanning 3 days. From this time, this date to that day, suggest a few attractions when I'm there and find me good Mexican places to eat nearby and keep everything under, $1,000, crazy request. So as you can imagine, kind of now there are multiple things that this query needs to do. One is, well, there are things running on different places on the web. And now my local agent, edge agent, needs to make sure that kind of it can communicate and then create such a plan, solve the problem, and then will provide me options. And then I will just say that, okay, this is good. I'm gonna, kind of take it. And then another use case would be display automation with a UI agent. For instance, we can be ordering food through, for instance, well-established ecosystem like WhatsApp or Facebook or kind of anything that you can imagine, but we cannot really access the kind of our accessibility tree or the HTML for many reasons, and we don't want to because that may be very complicated. But then we want to simplify the things, just like human. We have eyes, right? We have perception. So and we can interact. We can slide up and down. How are we going to automate that thing? And then it is running very efficiently. Another use case would be, for instance, multi-agent use case. Kind of we are trying to execute something, make a plan, and for instance, how will recently US imposed tariffs impact my stock portfolio? Create a report by looking at the forecast on the web and summarize the analysis in a PDF document. So you can imagine, like there are many things here now. These agents has to, I mean, it's not local anymore. It has to be local and on the web, and everything is going to require better, robust planning solution, better data harvesting, high accuracy solution, and ability to understand user query and what user already has. So many of these things will also require multi-agent interaction, not only multi-turn but multi-agent interaction. And as a wrap up, we can go to the next slide, Ramesh, if it's okay. So what I wanted to highlight again, that this effort around agentic web is very critical, and as Qualcomm we are we are on the front, maybe frontier of this effort. We would love to collaborate with the NANDA community closely, and make sure that all together we can create this vibrant internet of AI agents. And our take is Qualcomm is very committed to get such solutions running very efficiently on mobile devices, on edge devices, on device, because that's how we optimize everything we do. And through this, I have no question that it will unleash a new wave of internet of AI, maybe. Yeah, Ramesh, those are the things that very briefly I
Yeah, this
put
is
together. Sorry.
fantastic.
This content is old, by the way, because kind of I was aware of this only a couple of days ago. So kind of as much as I
Yeah,
can.
no, this is so critical. So Fatih, I'll ask you one question because we are slightly out of time, but if you can stay on and answer some of the questions in the chat, I'll ask you one question, which is, I think Qualcomm might be one of the few companies that's thinking about consumerization of the agentic web very quickly, because obviously Qualcomm is a leader in creating, phones and laptops and a lot of edge devices, chips
Right.
for edge devices.
Right.
So what about going beyond that? What about thinking such as, local communication through Bluetooth and so on, as opposed to the way we're thinking about serving AI agents, which is always through some cloud solution. We're still going to have, Jessica from FCC next in a few minutes after you. She's thought about this a lot, right? About different spectrums, different bandwidths. But I would say there's local communication like Bluetooth or direct Wi-Fi. Do you think that playing a role in thinking about agentic web in unique ways, just like IoT was transformed through local communications?
That's a very good question for many reasons, because Qualcomm is manufacturing such Bluetooth devices and then Wi-Fi, and Qualcomm's strength is in communication. And I talk about things about web agents, financial agents, document agents, personal DB agent. But kind of, for instance, imagine there is an XR device, and then XR glasses is kind of very low power device, and then some of the processing can be done here. So some maybe agent is running on the eyeglass, but then you have companion device, maybe your phone or like some AI brick, kind of, or your laptop, and some of them needs to be executed there. And you have also your headphone, right? Kind of some of the maybe the information will play back through your denoising headset, expensive one. And of course we have workstations and everything outside, on the cloud. So we are trying to make sure that agentic AI solutions would streamline developing such solutions for autonomous vehicles, for XR glasses, for mobile sets, and having running it through, for instance, Bluetooth or Wi-Fi or any kind of RF kind of channel is very critical. And how you would compress the data, represent the data, what is exchange between those agents becomes a kind of big question and critical question, because as much as you want to communicate everything, there's limited bandwidth, and power is the key there. And we are trying to optimize everything. There is trade-off between the accuracy, where you run, how fast you can run, how power efficient you can run. So this is a challenge. This is a big optimization problem. And hopefully, maybe even there will be another agent is solving such a challenge. But that's a good point. As much as I can talk without, kind of my legal team asking me why I'm talking about this, I can say that we are very much interested in it. Yeah. Yeah.
Excellent. I just wanted to kind of plug that the Nanda community also runs working groups, and one of the large working groups is actually Edge AI and Tiny AI. That's led by Aditya at Microsoft. So we hope Qualcomm will join this effort. Fatih, thank you very much. Please stay on to answer some of the questions in the chat if you have a few minutes.
It was a great pleasure. Thank you, Ramesh.
All right. So I'm going to request Jessica Rosenworcel, former head of FCC, to join. And Jessica, to get started, we have a small surprise for you. So what we're going to show you is how we can create a Jessica agent in matter of seconds. Okay. So anybody can go to join39.org and you can sign in. And I'm going to start creating a Jessica agent here on the fly. So there is, agent named Jessica, and we're going to, have your username for Jessica. And all I did was I just asked Perplexity about, who's Jessica, and share the details of her background and her work at FCC. And I just kind of copy pasted, everything that Perplexity told me about you. Hopefully it's correct. And I added that as part of your background. Okay, here, your education, your work at FCC, and so on. I just copy pasted it here. And then I said, anything that you answer, make it sound, usually make it funny. Okay. And then we have your chat ready to go. So, these are hundreds of different agents that people have created, some of them right now online. So there's a Jessica agent, and I can say, hey, where did you study? Right? That's the Jessica agent. And it says, hey, you studied in Wesleyan, and it's trying to be a little bit more funny. And then, we can ask some other questions, or we can say, hey, instead of being funny, can you maybe speak in a different language? Okay. Let's see if I can do this. So I'm going to say, maybe answer in Spanish. All right. And there you go, Jessica. You're going to start speaking in Spanish. What did you do at FCC?
Not Jessica.
This is a different one.
Oh, sorry. There's another Jessica, I guess. Let me see. Oh, that is Jared. Okay. What did you do at FCC? Okay, and there you're speaking Spanish. And the point we're really making here, Jessica, is that there was a time when getting a landline phone was very complicated.
Yes.
Now we can get on WhatsApp or Messenger and start communicating with each other in a matter of minutes. And soon we'll be talking not just in raw language like how we talk on Messenger or WhatsApp or iMessage, but we'll be talking to each other through agents. So and by the way, this is a dedicated page for you, jointender.org/chat/Jessica. So it's kind of your agent that you can update, modify, and so on.
Well, thank you for showing that to me, and I can definitely confirm that my agent speaks better Spanish than I do. Thank you also for having me here. I'm going to do something different than the last folks presenting. First, I'm not going to have any slides, and second, I just want to take advantage of my historical perspective from leading the Federal Communications Commission and talk a little bit about the NANDA community and more generally what I see as relevant precedent as we migrate towards an agentic web. Because obviously everyone here knows we are moving from a universe where we have more than 1 billion websites to one where we are going to have maybe 1 trillion or more agents transacting over this decentralized architecture. I mean, it's a profound change in the way we communicate. And so it's worth asking, what has happened in similar inflection points for communications in the past? And so I see 2 historic examples that I think are really interesting. They're not perfect parallels, but they're close enough that I think they're worth our time and attention because they both helped facilitate organization, trust, and made it possible to do more communicating at scale. So the first example is just actually simple numbering. In the 1940s, we had all of these different phone companies, and everyone who had a phone, it was only about half of the population. They had all kinds of different alphanumeric phone numbers. And every different community had different systems, and this made it very complex. So AT&T and the Bell system came in, divided the country into area codes, and came up with a uniform numeric system. And with that uniform numeric system, it suddenly became a lot easier for the operators who were physically connecting calls to actually connect them, which facilitated a transition to automation. And eventually, this system became something that was called the North American Numbering Plan Administrator when competition came to the marketplace and AT&T and the Bell system were not the only phone company in town. And quietly in the background, the North American Numbering Plan Administrator has created a system where there's uniformity and trust, and the distribution of phone numbers is a known activity. There's identification, there's a capacity to authenticate now with stir-shaken solutions, particularly on IP portions of networks. It is one of those systems that got created when there was a new inflection point in communications, which was telephony was really expanding. Now, the second analogy that I see actually comes from the early era of the web. We all take it for granted. Now we go to our URL and we type in something and we bring up banks or email or anything we're looking for. It didn't start that way, as everyone here knows. And in fact, the early web address system was largely kept, in fact, manually initially by a computer science researcher at the University of Southern California named John Postrel, who had worked on early DARPA initiatives associated with the internet. And he was keeping this registry of websites and started to evolve to the DNS system, and he was still keeping it. And in fact, he was so influential that he actually distributed out the top-level domains to countries around the world. It's why, for instance, .fm, which you might think involves frequency modulation and radio systems, actually is for the Federated States of Micronesia. So we have one computer scientist who's basically keeping the phone book for the entire internet. And over time, instead of just calling it something that was happening at this office at the University of Southern California, it became called the Internet Signed Number Authority, which then folded into an organization called ICANN, the Internet Corporation for Assigned Names and Numbers. Originally, ICANN oversaw this element of the web through a contract with the Department of Commerce, but about a decade ago, it was floated into a multi-stakeholder environment and exists today as a nonprofit that has 16 global board members and 4 additional board members from the Internet Engineering Task Force. And what's similar to the North American Numbering Plan Administrator and what Project NANDA is proposing is that you came up with a system that operates quietly, that offers organization, trust, and makes it possible to grow new communications at scale. And ICANN today is responsible for top-level domains, distributing out country domains, and also, maintaining the DNS, which is like the internet's phone book. And so I think that those analogies are really useful because at an inflection points when we were about to change to a new form of communicating and see what might have even been exponential growth possibilities from it, there was some system of organization that created trust. And that seems to be an essential component of navigating these transitions. And it's why this kind of registry system resonated so much with me. So I told Ramesh I would just start by talking like that, but I'd be happy to take some questions if those historical analogs are of interest.
So fascinating. I wish some people at MIT can just have a list of all the agents and manage them, like the story you just mentioned from USC. I think Jessica, I mean, the challenge here is that even if you compare with IP addresses, the namespace of this 4 8-bit numbers is only about 4 billion. And out of that, about only 10% get used. About 400 million actually get used because of, they're not properly packed. But if you think about agents, we have 8 billion people and, about 5-6 billion smartphones. Every one of them is going to become an agent very quickly.
Yeah, the numbers are like radical in a way that nothing else has ever been before for communications. And you think about those early examples I gave you, and they seemed enormous at the time, and even exponential in terms of growth. But it's nothing like what we are facing.
Yeah. So what are some lessons about centralization, decentralization, re-centralization that has happened? Even for Spectrum, for example, it's supposedly it's an auction, but some large companies kind of pick it up. So what's some lessons here that you can map, or anything from history we can learn from, about when you set out with the intention of creating very distributed, very decentralized entities in the spirit of fast innovation? Sometimes we don't get the design right. What can we
Yeah, I think it is hard to build global movements with these things. There are always dissatisfied entities. I think ICANN has been contested throughout its history, and I think that's always been a challenge. The North American Numbering Plan applies in about 20 countries, largely the Caribbean, Canada, and the United States, but it does not apply in Mexico. So I think geopolitics is a challenge associated with the development of these kind of systems where they're fundamentally decentralized, but you'll have governments wanting centralization that is not born of some, multi-stakeholder process, but instead is something that is owned by the government. And I think those tensions have been consistent throughout history. ICANN is sort of the best example I have of building a multi-stakeholder system that's global, that has civil society, government actors, and engineering authorities working together to try to support the domain name system. But I don't think they're perfect. Nonetheless, they do seem to hold together, the systems we have today, and I think that's not nothing. You asked some interesting questions to the Qualcomm engineer before about Spectrum. I got lots of thoughts about that, because I think as we're migrating from, a device-to-device world with people to device to machine or agent, or machine-to-machine and agent-to-agent, we're going to multiply the communications around us in a spectacular way. And of course, the airwaves around us, which manage so much communications, are finite, and their efficient distribution is really important to prepare for this moment. And making sure we have the optimal mix of licensed services, which we create through auction, and also unlicensed possibilities, which we make available through systems like Wi-Fi, has always been important, but it's going to be even more important to manage this traffic and the growth of machine-to-machine and agent-to-agent traffic going forward.
What are your thoughts on any similarities about throttling or a preferred access, or a lot of things that happen in the internet era? Are there risks in the agentic world? Because
Yes.
as I said, first of all, the numbers are going to be huge. Hopefully, there are many players, so there's some kind of a checks and balances in the system. Do you think there is a concern that like very mom and pop stores or small shops will not get certain resources, they will not get listed properly? Will there be some kind of auctions, certain kind of resources? How do you see this playing out?
I think
What we need to do to
yeah.
protect what we need to do to protect the main street from the Wall Street?
I think that with communication systems generally, you always have questions of non-discrimination and discrimination with traffic.
Right.
You can set up compensation systems for the exchange of traffic that is biased towards one or the other. You can set up regulatory regimes that require non-discriminatory treatment. You can adapt protocols that make everyone put a premium on non-discriminatory treatment. You have to be really intentional about what you do, because over time, most commercial actors will have incentives to favor some traffic over others and to build relationships into their infrastructure that are discriminatory. So I think that's a really important question to ask. I don't have clean answers for you right now, but I do think it is something that everyone needs to keep an eye on.
Yeah, I think I'll share with you one of the open secrets in the community. I'm not taking any sides. So if you think about just Anthropic versus OpenAI, so Anthropic released MCP, and the rumor is that one of the reasons they had to create MCP out there is because OpenAI was setting up relationships with individual companies, like Shopify, like Booking.com, and so on, so that you can access those services directly from ChatGPT in OpenAI.
Yeah, I mean, every commercial actor, particularly those that are large and powerful, will have incentives to try to build those relationships. So how do we build a framework that is more compelling than a fragmented universe like the one you just described? I think that's the question.
Yeah, and so I think the rumor is for Anthropic, the right way to handle this problem was to create this open source protocol, Model Context Protocol, MCP, that we just heard, so that it doesn't require for Booking.com to create a special relationship with, say, Google or OpenAI, but once they open this up, anybody, any language model, including
Can use
Anthropic,
it. Yes.
can use it. So in
Yeah,
a way,
no.
it's a big win for the open ecosystem, because not the dominant player, but maybe the second or third dominant player like Anthropic was able to open up this ecosystem. My question
Yeah,
to you
and by the
is,
way, that
how do
comes
we
from
make
the
sure?
power of having some competition in this space, where you
Right.
get different incentives, and the power of openness is its own network effect, and choosing to pursue that has opportunities for growth here that I think
Right.
MCP allows us all to exploit.
Yeah. So whether this rumor is true or not, I mean, clearly, I know Nick is here. I'm sure he has no permission to address this question, but Nick, you're welcome to come on and talk about MCP and how it benefits the overall ecosystem. Although OpenAI also had some other good solutions before MCP, I would say technically they're very solid as well, but MCP took on. So I think it's just an interesting play. And as I showed a diagram right in the beginning for kind of the landscape of a post-AI world, the communication is only a tiny, important, but a tiny piece of the puzzle. As we said, like indexes and registries and exchanges of economy, the economy of agentic web, all these things have yet to emerge
Yes.
out there. So what are
But
some?
there are always going to be commercial actors who have an incentive to use their scale to make them emerge and leverage them into their relationships with favored other commercial actors. And so what you were describing before is something to be on guard for. But I think that there is interest in seeing something that is more akin to the predecessors I described from numbering and the emergence of the internet, which is a system where all comers have a fair opportunity.
Yeah, I think the good news is that, and I have been very fortunate. I have talked to pretty much all the top leaders in every company that matters in this space. And nearly all of them are very committed to creating an open innovation ecosystem. And we just saw that MCP, although it came from Anthropic, is now being adopted by Google and OpenAI
Very
and Microsoft
broadly,
and everybody
yes.
else. And same with A2A team at Google. When I talk to them, they're very eager to include everybody and be inclusive. So I hope this trend continues. I would say the growth in AI in general since 2013 has been possible because the community, for some reason, has decided to do everything in the public, as opposed to if you look at the community of autonomous vehicles, where every player is doing this in a closed ecosystem.
Yeah, that's a really good contrast, actually. I hadn't thought about that one. It's a really good contrast.
Any closing thoughts, Jessica?
Just that numbering systems and the DNS system don't feel radical to us today, but they once were. And we developed systems to create trust around them that allowed them to commercially thrive and really create the world we know today. We couldn't imagine a world without using the internet and going occasionally to a web page or using the phone and talking to someone. And I just see the inflection point that we're headed to as even bigger than that. But we should borrow some of our learnings from the past as we migrate there, making sure that there's trust in this organization and that we can grow it at enormous scale is really important.
Yeah. Thank you, Jessica.
Thank you.
And please stay on for some
I will.
amazing demos that are coming up, and also there are a lot of questions for you in the text.
Okay.
If
Thank
you
you.
can answer them. And Nick, if you want to come up and share any thoughts, please come on back on and share with us how you think about kind of open innovation ecosystems. All right. With that, we have a power-packed next 30 minutes. Don't blink, because you're going to see some amazing reference implementation and code and demos and research and ideas. And to lead that, we have a brilliant scientist from MIT, Pradyumna Chari. Go ahead, Pradyumna.
Thanks so much, Ramesh. Thank you so much, everyone who has joined in to our virtual summit today. It's been some very exciting talks, and yeah, happy to take it forward from here and talk about some of the work here that we've been doing as part of Project NANDA and building up to some reference and implementations and demos that will be shown by my colleagues Ayush and Maria right after me. So a lot of the work that we do here at NANDA starts with some academic work, writing research papers as part of a big consortium and group of brilliant people across industry, academia, and so on and so forth. So before I start talking to you about some of our core contributions as well as the demos, would strongly encourage you to check out our papers from this link with the QR code, and I'll talk to you more about joining this amazing writing group shortly. Ramesh has touched upon this idea of the index, the NANDA index, which is this quilt-like registry aggregator that we view as sort of the core piece of this Internet of AI agents to enable this identifiability, discoverability, and handshake between distributed agents across distributed ecosystems. So the core piece, as I mentioned, for that from Nanda is this idea of an index. The index is a lightweight sort of, let's call it a lightweight aggregator of information of very, very static, not changing very fast information associated with agents on this Internet of AI agents. So for example, the index consists of agent names, aspects such as their ID, what we call an agent facts URL, which is a detailed metadata schema that I'll talk to you about shortly, as well as aspects such as routing and time to live and so on and so forth. The core design philosophy of how we are viewing indexing, routing, and registry on this Internet of AI agents as a function of agents being ephemeral, autonomous, and sort of basically self-performing is that we intend for this index to be lightweight, static, and broadly interfaceable with industry registries and so on and so forth, and all of the critical metadata and information that is necessary for agents to know about each other, find out how to talk with each other, and so on and so forth, lies in what we call an agent facts schema. Now, as I mentioned, each index entry links to this agent fact schema, and the agent fact schema is a detailed sort of metadata of all aspects that are necessary for agents to talk with each other. These include aspects such as identity, endpoints, skills, sort of preferences, monitoring such as telemetry, trust and verifications, auditing, so on and so forth. Now, a lot of you may think that this looks quite similar to aspects such as agent card from Google, similar things from Salesforce. And this is true. Metadata schemas are going to be very, very important. Think of agent facts as one step beyond a sort of superset of all of these with very critical aspects such as moving beyond self-certification of skills to auditability of skills, trust, verification, telemetry, and so on. So these are the two critical components of the NANDA index. This avenue of enabling discoverability, identifiability, so on and so forth on this Internet of AI agents. Now, the index itself has, the index architecture is designed to be extremely diverse in terms of agent resolution paths to allow for different types of agents and agentic entities to be listed and to be able to operate via the index. The first type of entity is agents that are directly registered as part of the NANDA index. So they have an entry on the index with their agent name that is certified and authenticated by NANDA that links to their agent fact schema, which can be hosted anywhere. The point of agent facts is to be decentralized. The agent owner can decide to host it themselves, decide to host it on some third-party avenue, whatever they want. The agent fact schema will then link to the sort of metadata relating to the agent, including usage formats, endpoints, and so on and so forth. But of course, we do not want to limit the NANDA index to be only for agents that are certified, authenticated, and registered via NANDA, but also for other critical types of agents, including via enterprise registries. So for example, if an enterprise entity does not want to directly list their agents on the NANDA index, we allow for the enterprise registry to be indexable from the from the NANDA index, and therefore via the registry, via the enterprise registry, which allows the enterprise entity to certify, authenticate, so on and so forth, their agents. Via this enterprise registry, we are able to access this enterprise agent fact schema and then move from there. And finally, the third type of resolution path that the NANDA index allows is for enterprise certified and authenticated agents, but those that are directly also visible on the NANDA index, allowing for easier discovery and search and so on and so forth. And they again, from the NANDA index, from the lightweight NANDA index, are directed to the agent fact schema and from agent facts URL, and from the facts URL, move forward to understanding the agent, working with the agent, setting up the handshake. Very important point as we build this NANDA index is the NANDA index is only important for that initial first handshake between two agents. When you want to discover an agent that, for example, does some specific type of, let's say, medical diagnosis on the Internet of AI agents, you would use the NANDA index to find this particular agent by leveraging the agent facts metadata about their skills and so on, and find that agent endpoint. Once you've found that endpoint, then you don't need to come back to the index again. Then it's a completely peer-to-peer system where you establish the communication with that agentic entity and talk to them independent of the NANDA index. This architecture for the NANDA index, as well as several other critical components, such as why we need a new index architecture in the agentic ecosystem, or why we need a new, or what are the comparison between different types of indexes or registries that exist out there, or what are some security considerations for this index registry, all that kind of stuff. All of these are questions that we've been considering as part of the NANDA writing group and NANDA papers community. And if you're interested, please do follow this link over here. We have a detailed onboarding guide where you can join the NANDA writing group as a contributor. We ask you to first sign up and help us with or start off by reviewing some of the existing NANDA papers on the NANDA papers GitHub repo, which you can follow from this link. And then once you've reviewed the papers, once you've contributed to their refinement, then we allow you to onboard as part of a contributing member, and finally as part of a core writing group member. So would encourage you to go to this link, look at all of these steps, this 5-step process that we have in detail, and very, very happy to have a bunch of contributors for this writing group. Now, so what we just discussed was the NANDA index architecture, the sort of fundamental infra piece that we believe will enable discoverability, identifiability, and handshake across organizational silos in a distributed agentic internet. Now, before we move on to the demo, we have, of course, set up a bunch of reference implementations for all of these things that we'll be talking about shortly. But before that, I'd like to talk to you very briefly about how this index piece plays a role in onboarding or joining this Internet of AI agents if you wish to participate in it. So as I mentioned, the index piece is sort of the base layer, the first layer, via which you can get what we call an agent name that Ramesh demonstrated as part of Join 39, which will also be demonstrated later. This registration, this core registration on the index and getting your agent name is facilitated by our index API, which I'll show you shortly. After this, the next thing that you do is create your agent facts and then host that agent facts somewhere of your choice. Now, as I mentioned, this is completely decentralized, so agent facts can be hosted either personally or on some aggregator portal, so on and so forth. We will show you a reference implementation for a agent facts aggregator portal that allows you to host your agent facts, have them available and indexable by the NANDA index, and therefore allow for handshakes between agents. And of course, the final piece is once you have registered your agent name, hosted your agent facts, finally you go ahead and host your agent on a public endpoint, update your agent facts and index entry accordingly. And my colleague Ayush will talk to you about our agent adapter SDK that will allow you to host agents very, very easily, interface with the NANDA index, and try out some of our aspects. One of the core aspects, one of the key aspects to emphasize is NANDA is built on an ecosystem of partner entities. NANDA is just a lightweight index, or the NANDA index is just a lightweight index that allows you to be discoverable across entities, but it's really enabled by a decentralized set of partner entities. So for example, a typical workflow for someone who wants to join this Internet of AI agents would be first using some kind of front-end registration portal, such as Join39, which will be shown later, which is similar to GoDaddy in the sense that it allows you to get your name and get your entry on the lightweight NANDA index. Once you've done that, you can then list your agent facts on any of those agent facts listing entities that may exist out there, including our reference implementation, but really it could be any agent facts hosting entity, including hosting yourself. Once you've hosted the agent facts, you can then host your agent in any of the hosting services that may exist out there, including some of the common ones. You can host it locally, you can host it using some fourth-party, third-party service, and anything beyond that. And these are very analogous to how web hosting works in today's web ecosystem, going from DNS to GoDaddy, which allows you to buy a domain, to Route 53, and finally to cloud hosting of agents. And again, as I mentioned, NANDA is intended to be extremely diverse and democratic. So for example, if there are enterprise registries that are not directly listed on NANDA index, the NANDA index allows for a link to these enterprise registries who may have agents behind a silo or something like that. And the same resolution path continues that way as well, including front-end registration via their maybe proprietary service, agent facts hosting, and then agent hosting solutions. As I mentioned, the NANDA index is built on top of a diverse ecosystem. And to kickstart this ecosystem, we have some reference APIs and implementations to allow for people to build services that allow to add entries onto the NANDA index or host API specs or host the agent facts. And we have a couple of GitHub repos already for this, which you can find at github.com/Project NANDA. This repo, for example, is the API spec for our lightweight NANDA index that allows you to add entries to the index. An entry to the index obviously is extremely lightweight. It's just your agent name and your link to the agent facts schema. And this is an API spec that allows you to do that. And so anyone can build their own GoDaddy basically on top of the NANDA index to allow for people to register on the NANDA index. The second reference implementation that we have over here is this agent facts sort of aggregator portal, which allows for people to host their agent facts publicly if they wish to do it that way, with endpoints to create agent facts, update them, and so on and so forth. So would encourage you to check out these specs and schemas and build on top of them to utilize this NANDA index and ecosystem. With this now, I've talked to you in detail about the foundations of the NANDA index, how the NANDA index interfaces with the decentralized agent facts metadata to allow for agent discovery and identification at scale. Now I'll hand over to my colleague Maria, who will talk to you about Join39, this front end to onboard to the NANDA index and the registry of AI agents. And Maria will take you through this in detail. Thank you.
Thank you so much, Pradyumna. So hi, everyone. I'm Maria. I am a part of the Project NANDA team, and I'm going to walk you through how to onboard into the Internet of Agents. So I know Ramesh already gave you a sneak peek of what's possible, but let's dive deeper together. So just head over to join39.org. Right here, you probably already know it. This domain is in the chat. So when you land on the site, there's a lot going on, but I'll guide you through the key parts. So first, let's start with the tools page. So here, you'll see a collection of MCP servers and context agents from different registries. So you can explore, search, filter them, and once you connect your agent, you can actually use those tools. So you can also upload your own MCP server to the NANDA index so that your agent or other agents can use it. Right here. So yeah, next, let's look at some existing base agents on the NANDA index. For example, you can see agents like Predumna over here. And when you click on it, on the agent facts, you can view the agent facts card for the Predumna agent. These are hosted by our partner, list39.org, in a public JSON format. So as Predumna mentioned earlier, the list39 APIs are open source, and we encourage others to build their own agent facts hosts that follow our open standard and schema and integrate into the index. So even better, you can actually talk to these agents. You can ask them things like, what is your work experience, and explore their capabilities directly. So and yeah, we can see. All right. So now let's say you want to create your own base agent. So after signing in securely with Google OAuth, right here, you land into your personal dashboard. So here you'll see your agent facts, which include basic info like name, label, description, certification, endpoints, and so on. So you can customize this anytime. For example, my agent facts link is here. So it's list39.org at Maria.json, so you can see. And it reflects my current agent profile. So when I update my description from the dashboard, it automatically updates the public profile page as well. So for example, I can change agent name, I can say Maria's agent, and then click on save. Now here, you see it changed the name automatically. Right. So next, I can show you how to create your own base agent by changing your agent profile in your dashboard right here. So all you need to do is just enter a name, description. You can take it from Perplexity or your resume or LinkedIn, anywhere. And you can also share a system prompt to shape your agent's personality and behavior. So once the agent is saved, your agent becomes discoverable in the agent directory. So you and others can chat with it, share it, and even post it on LinkedIn or use it in a personal or business content. So my agent would probably be somewhere here because I created it before. All right. So then also from your dashboard, you can view conversations people had with your agent. So you can see what questions they ask, what they want to know about you or your business. You can review it right here. And yeah, this is the core idea. So bringing it all together into the Internet of Agents, it's powered by the NANDA index, integrated with platforms like List39 and connected through open tools and APIs. And this onboarding flow gives you full stack entry into the emergent Agentic Web. And with that, I'll hand it over to Ayush, who will dive into the adapter SDK and chat applications built on top of this infrastructure.
Hi, yeah, just give me one second. Show my screen. Yeah, can you see my screen?
Yeah.
Hi, yeah, thanks, Maria. So we've got some context about like how you can use the NANDA index to basically register an extremely heterogeneous set of agents. You can have like your own like MCP tools. You can build your own like base agents, which are reactive. You can also build like more preactive A2A agents. At some point, you might want to build like some kind of NL web agents. So when a lot of these different kind of agents come together, there'll be like a lot of opportunities to build extremely new kinds of user experiences. But there is like some inherent sort of challenges that need to be solved along the way. So one of the challenge that needs to be solved is to build some kind of like a universal translator. So if you use the NANDA index to discover different kinds of agents, you might realize that because NANDA index is like a lightweight router, there can be agents which are very different from each other. So if an MCP agent wants to talk to an A2A agent, or from an HTTPS server you want to talk to an A2A client, these kinds of conversations can be extremely like multilingual in terms of the kind of protocols that are required. So at NANDA, along with the index, we're also trying to build a lightweight sort of translation layer called the NANDA agent adapter that will allow you to sort of have multiplexed conversations across many different kinds of protocols. And I'll walk you through what the objective of the NANDA agent adapter is, how does the SDK work, and show you a couple of cool applications that can be built on top using our agent adapter. Yeah, so consider this very simple conversation flow that Ramesh sort of talked about in the beginning. And you'll see that, imagine there's this person called Adam who wants to order like their preferred cake from their local bakery called the Moon Bakery. So Adam sends a message to Adam's agent saying, talk to the Nanda index and find where Moon Bakery is and send them a message saying, can I have my usual order? So Adam communicates with Adam agent over an HTTPS request, because Adam's client can be something like a web browser. It could be like a chat application running somewhere on your computer. And then Adam's agent has to do a bunch of things. So when Adam maybe says like, can I have the usual order for my daughter's birthday this weekend? Then Adam's agent needs to do a combination of discover and requests before it can send the message forward. It goes on to Adam's calendar to see when is Adam's daughter's birthday. Is it this Saturday or the next Saturday? It may go to Yelp's website to figure out which of the local bakeries are best to go to, what kind of raw materials are being used, what are other like requirements or constraints he'll have to specify, what the rating of the bakery is. And then Adam pings the Nanda index, which is just a lightweight router between agents, to figure out the agent for the bakery, and then uses the A2A protocol to send a message to the bakery agent. So before sending a message to the bakery agent, Adam used the MCP protocol to talk to Adam's calendar and something like maybe an NL Web protocol from Microsoft to talk to Yelp's website. Then Adam sends a message over the A2A protocol to the bakery agent, who receives the message from Adam and may add some additional context about what kind of stuff Adam likes, some past order history for Adam by talking to the bakery's MCP tools that are about their inventory or customer analytics, and then forwards a message to the bakery to make a final decision. So as you can see, like these conversations are extremely heterogeneous, and in the future, we'll see more and more specialized protocols being built for specific applications. And with Nanda, because we want to build a lightweight index that can enable open communication across the Internet of Agents, we want to augment the index with a very lightweight adapter that can allow universal translation of these conversations. So essentially, the argument of a Nanda agent adapter is, think of it like a universal translation layer that will allow MCPs, A2A, HTTPS, NL Web, clients and servers across all of these different protocols to talk to each other through like a very lightweight abstraction. So essentially, you can build an agent using any kind of agent development kit that you like. For example, you can just build it, let's say, using Google's ADK, and you build an Adam agent. But what you can do is, if you use the Nanda adapter SDK, you can take the agent you built, wrap it up with the Nanda adapter SDK, and essentially now this agent sort of gets these superpowers where it can translate messages across different kinds of protocols and enable seamless communication. So the agent is able to detect, oh, am I getting a message from an MCP server? So maybe let me act like an MCP client right now. Am I getting a message from an A2A server or an HTTPS server or an NL Web server, or like all the combination of specialized protocols that will be built in the future? And there's a lot of like what the Nanda adapter ADK basically provides is a domain-specific language to make this translation more coherent. And essentially what will happen is that instead of having a simple A2A agent doing the communication, we have an agent which is built with the Nanda adapter SDK that has this multiplexed translation capabilities. And essentially now you can just have a very lightweight capabilities provided by the Nanda index and the Nanda adapter to discover, register, and translate interactions between extremely different kinds of agent protocols and agents that are being built across a lot of different enterprise and scenarios. And so the Nanda Agent Adapter SDK is open source, and you can get started. It's pretty easy to use, and it's open source. It's an open project. We would love to appreciate any like contributions, capabilities. We're always looking to build integrations to newer kind of protocols. So we'll appreciate any kind of open source contributions you guys want to make. And now I want to give you a simple demo of how you can use this Nanda adapter and the index to build an interesting chat application where your agents you don't just talk to an agent as you saw with our base agents, but you talk via our agents to have more successful conversations between people. And essentially, to use the Nanda adapter SDK, basically what you do is you need two things. You just need a machine with a public IP. So I just went to EC2, I created a machine where I'll host my agent. So another benefit of using the Nanda adapter agent and the adapter SDK is that even when you're having these like global conversations with agents all over the internet, you always get to keep complete control, complete security, complete access to all the conversations, the credentials that you may want to provide your agent. So the agent is completely hosted on your local machine, but the capabilities that NANDA adapter and the NANDA index is they provide the global discoverability. So you sort of have the best of both worlds. So all that I did was I went to EC2, I got like an AWS machine with a public IP, and that's where I'll host my agent. And using the NANDA's infrastructure, I'll talk to agents all over the world. So the first step that I do is I get this machine and I just simply log in. I've just logged in and I just go and install the NANDA SDK. So you just go install the SDK.
I can't see your screen fully. Only like a center part is visible to me.
Okay, I can stop sharing and share again. Can you see my screen now?
Yeah, great.
Okay, yeah. So basically what I did was now I'm going to set up like an agent that can use NANDA's infrastructure to talk to agents all over the internet. So the first thing that I did was I went and installed, I just got an EC2 machine, like my own local machine, where I'll host the agent and then I'll use, and this is where my agent will sit. So all my conversations, all my interactions, all my credentials, all my traces will always stay in complete control of me. Like because NANDA is just a routing index, no data is ever captured, all the data stays with me, but it just gives me the capability to still be discovered around the web. So I just went to EC2, got a machine, and on that machine, I just installed the NANDA SDK. And what I do next is I can just use the SDK to start an agent object. And it's a very simple command where I just provide some kind of credential. So I provide some kind of an API key. I provide like a simple domain, which represents a public IP where my agents can be seen. So what the SDK is doing right now, it's sort of spinning up this agent that has these multiplexed communication capabilities with NANDA SDK. And it's also registering that agent to the global NANDA index. So that agent becomes discoverable. So this is sort of providing you like a good trade-off between having the ability to instantiate and keep your agents local, but also the ability to talk to a wide range of MCP servers, other A2A agents, HTTP clients that exist all over the internet. And in a very like secure, trustworthy environment. So yeah, it'll just take a couple of minutes, and basically you can use it to configure the scenario in a lot of cases. For instance, your agent gets, the first thing that happens is your agent is already been assigned an agent ID, and it has a public domain. For instance, I just created a random domain called chat4.host39, which is sort of a public IP for my agent, and I've created one agent. In principle, you could create like an entire army of agents that sit locally on your computer that interact with each other and may periodically speak to other agents on the global internet. And while this is being set up, so the NANDA SDK is public completely. It just takes a couple of minutes to set up, register you to the global index, but you also have an option to change your index. If you don't want to register to the current NANDA index, you can create your own index using our index API and register your agents to that index. So this is where the NANDA SDK sits. It's on GitHub. You can just go to GitHub, Project NANDA, NANDA SDK, and we have descriptions on all the things you need to provide. You need to provide some kind of like an LLM API key, the domain name where you want to chat, and a bunch of optional parameters. If you want a specific agent ID, or the number of agents you want to build, or the kind of agent registry that you want to register this agent with. And yeah, and you can just get started, start contributing. And okay, great. So our agent has now been set up. And when this setup process ends, what you get is some kind of like a authentication URL for the agent. So this is the URL that you see, which takes the agent ID that agent was originally assigned. Now I'll take this URL and I'll just literally just go to my browser and I'll use one of the many open gateways that you can do. So NANDA indexes agent is completely sitting on your infrastructure, but we have like a simple web client. Like it's literally a website on the browser where you can just log in and talk to everybody in the web, how you might talk to people on a website, except the data is entirely secure on your own device. So you can provide this agent all the authentication credentials for your calendar MCPs or like sensitive conversations you may have with other agents. None of the data is ever cached anywhere. And you literally just go in, I put my authentication, I just sign in with Google, and I get. And I'll just authenticate myself. So I'll just call it NANDA adapter agent V1. Yeah. So you should use the adapter agent SDK. So I'm in this web client where I can talk with any kind of agent now, just in a couple of clicks. And this is sort of my local sandbox. And through this single interface, I can talk to all kinds of people. For instance, this is like my own personal account. So I can send a message. Excited to be part of the NANDA ecosystem. So when I send this message, essentially this is my client sending a message. And now what happens is when I type this message in the browser, the NANDA adapter allowed my web browser, the client, to talk to my LLM over an HTTPS server, which improves my message, makes it sound more formal, and then uses the A2A extension of the adapter to send a message to my other account, which is at Ayush.
Are you sure fonts are very small when the screen is shared? Can you zoom in?
Yeah, I can.
That's much better. Yeah, that's fantastic.
Sorry.
Go back to where you were. One more zoom. One more zoom. That's good. Fantastic. Yeah. This is good.
Okay. Great. Yeah, so you can just send a message, talk to any other agents, and what I can also do. Oh, sorry. Yeah. Yeah. Sorry. No. I think. Yeah. So basically, then I can use my sandbox to engage with this network of MCP tools that exist over. Can you see my screen? I think it's.
We can see your screen. Yeah.
Oh, it's. Why didn't realize whether it's like. Oh, I think my.
Okay, pick a zoom level that's good for you.
Yeah. Revert to a setting that works for you.
Yeah, I think my. Okay. I think it's like just my computer issue, but sorry. Yeah. So the next thing that you can do is you can just talk to your local personal agent assistant how you were talking to your base agent. So I could just ask it questions like, what is the capital of India? And it'll just respond back to me. And what I can also do is I can use this to send message to other agents. For example, I may send message to Ramesh Raskar. This is a great workshop. Thanks for hosting. It's going to be amazing. And I can use the sandbox to send a message to an A2A agent. I can also use it to talk to a wide network of MCP tools. For example, the next NANDA event is happening in July in Boston. So if I want to attend there in person, I can be like, can I find me hotels near MIT? And yeah, sometimes the request takes like a couple of requests too. So in this, I just sent a message to a hotel booking MCP server that's sitting inside Smitherees MCP registry. And the NANDA index is just routing the request to the appropriate MCP server by helping you find the corresponding details. And I get a response saying, oh, here are the best 5 hotels you can find near MIT in Cambridge. So you can do these kind of multiplexed conversations through the NANDA interface and use the NANDA index and the adapter to be able to build agents that are secure. Conversation always stays on device, but you are still exposed globally. So other agents can discover you, they can send you messages, and you can have very flexible conversations. Yeah. And thank you. And I'm happy to take questions, and I'll give it back to Pradyumna now.
So Ayush, I just want to kind of make sure everybody realizes it, that the two main innovations here. Pradyumna, do you want to bring up John while I'm talking?
Yeah, John.
The two main innovations here, right? One is the index itself, and the second is this universal adapter that allows you to talk to any type of tool or agent that's out there, whether it's MCP, HTTP, NL Web, and A2A, and so on. Can you just spend a minute just kind of emphasizing what that adapter means and what that index means and why it wasn't supported so far as part of MCP or A2A, or why they cannot support it right now?
Makes sense. So the adapter exactly. So when we say adapter, we are not building a new agent communication protocol. Like there are a lot of agent communication protocols that already exist. So the whole goal of an adapter is just to sort of help you set up on the translation between two agents. So for example, when there is agent 1 and agent 2 that want to talk over A2A, they'll still talk over A2A, but this now agent can talk to another agent over A2A or MCP or HTTPS. And the reason to build this now and not before is because a lot of the protocols from MCP or A2A have largely been built only for like enterprise silos, where like there is like no need for like cross protocol interoperability in some sense, because since all of the protocols are like built inside an enterprise, it's like closed world where all agents may run on the same protocol. You don't really need any kind of a sort of translator to sort of translate or adapt between different kinds of protocols. But because we want to build a vibrant open internet of agents, where different agents may want to run on different kinds of protocols, and the NANDA index will help us discover them, what the adapter basically does is it just helps us set up the handshake after the index has worked. So with the index, I can find where the other agent sits. With the adapter, I can initialize my handshake, and then you can go back to using the original communication protocol to have a flexible communication.
Go ahead, Pradyumna.
Awesome. Thank you so much, Ayush and Maria. I think incredible demo. I can see some comments in the chat that it really explains the concept of Nanda so easily, and I think great job. Before we move on to the next set of speakers, I wanted to bring John Zinke, who's a core contributor for Nanda from the beginning. And John is literally one of the people because of whom we have internet today, because John participated in ARPANET and he's done such amazing work after that. So John, just wanted to get your quick thoughts on the NANDA index, what you heard just now, and what excites you the most about this concept over here.
What I like is we're in early, and so we have chances to put in hooks that's going to help the growth in the future for the scalability. And one of the things that you can notice is like, what is the definition of an agent, right? So today when Jessica had her agent made for her on the fly, you added a little bit of state, but there was this big LLM hanging out behind it, and the LLM was emulating her state, right? And then you had a conversation with her, and it remembered the conversation, which adds to the state. So what is an agent? Is it a type? It's one of these persona agents, or is it the specific state with Jessica? Is it the conversation that you're having right now? Or is it the next level down of this thing is I now am going to have a relationship with this agent between two agents, and now the environment in between, the communications path, where do I move the state? Think of an agent like in the early days for the agents, we were working on mobile agents. So the idea would be, oh, I need to have 3 million interactions between this agent and that. Maybe it's better to send the agent to, in those days, it was send them from Boston, from MIT to Stanford, but now it's going to be from the Earth to the Moon or to Mars. Then you have a lot of interactions, and then you send the state back. So how do you put all of those kind of interactive parts into the agent architecture? Because it's a lot, the communications between agents is a lot more complicated than just client server web accesses. It's going to be very much more interesting. So that's what excites me. How we're going to deploy these things at scale.
Amazing, amazing. So I think you touched upon actually a lot of interesting stuff, including how to serve agents, resolve agents, how all of that will work. And a lot of these are open problems that Project Nanda is indeed focusing on moving forward. Thank you so much, John. Thanks for your thoughts. And yeah, amazing to hear from you. Yeah, as I said, you've seen it all happen once before, right from the driver's seat, and
5 times before. Once a
five
day.
times before. Hopefully, the sixth time is the most fun. Thank you so much, John. Over to you, Ramesh.
All right, fantastic. So next we have Ashish Bhatia from Microsoft, and Ashish, followed by Rakesh, are giving us a rapid fire 10-minute overview of how they think the space of agentic web and how Nanda is playing a role. Ashish, take it away.
Thanks, Professor Ramesh. How much? Can you guys see my screen or not yet?
Not yet.
Yeah. Let me see if this works. You guys can see the screen now?
Yes, go ahead.
Perfect. All right. So this example was quoted. I'll breeze past that and I'll spend time on some of the other slides. But this one is kind of near and dear to my heart. I grew up in a small town in India, and getting a rotatory phone took 2 years of wait time in 1980s. And what we got along with the phone was not just the device, but a thick directory, right? And what you could do is now you can search up phone numbers and call them if you want to. Imagine a world before that, right? You would have to walk down to a store and buy a service or a product, right? But with this directory, it unlocked the possibility of reaching out to anybody who's on that directory. If your business was not listed on the directory, you're kind of not visible, right? And we've been through this several times in the internet age, right? If your website is not there, then your business is not visible. And again, with DNS and internet, it created a global registry of facts and websites where you can kind of reach out and find stuff. Mobile took it a notch further, right? Now all of this information is available to you in your pocket. But again, app stores become how the serving kind of layer, how people find your application and does interact with your business, right? And the agentic web, we're going to need a Yellow Pages of the agentic web as well. And again, hopefully Nanda is addressing that, and we'll talk a little bit about that. Again, if your business is not represented by your agent, then it's not visible in this new agentic web that is taking shape in front of our eyes. So that's very interesting. I wanted to kind of share this perspective from a Microsoft Work Trend Index annual report, which was released a little bit earlier. The way we see the role of agents evolve in our work life and kind of personal lives as well is divided into 3 phases. What we saw in the last 2 or 3 years with kind of LLM-based agents, or assistants, I would call them, is the first phase where human is interacting with an AI assistant and getting a response for the query that they are kind of putting forth. Now that itself is super useful. A lot of these early assistants were just grounded in the world knowledge, but we started to ragify them and kind of bring on enterprise knowledge to kind of make them more interesting and aligned with enterprise goals and so on and so forth. We're going to see next, and starting to shape here, is the phase 2, where humans are working with multiple, almost digital colleagues, right? These are in true sense agents, and there are a few ingredients to this, right? Think of a digital colleague or a human colleague as well, right? They remember context over a period of time. They don't suffer from session amnesia, right? That every new session you have to remind them of, hey, why are you here? What task can you do for them? So that is going to become super interesting. And these colleagues can then go do things for you. A great example that I always use for this kind of mindset is think of the deep research agent, right? You can set a task for it and let it go do things. It comes back, you can review the results, you can tweak it, you can take some bit of it and then do something else with it. But imagine multiple digital colleagues like that. Also, deep agent is one thing. It's kind of grounded in the world knowledge, but spinning off deep agent like or deep research like agents in your enterprise context where layers of information is access controlled and privilege controlled and so on and so forth is more interesting and hence more complex as well, right? So that's something to watch out. And then step forward into phase 3 is where humans are working with teams of agents in a team setting, right? So it's not just for your own productivity, but for your own workforce productivity. A lot of that is human initiated and agents going autonomously, finishing off tasks on your behalf and things like that. So that's super interesting. I feel we are somewhere in between phase 1, phase 2, and we're kind of transitioning fast to kind of phase 2. It is a similar example that Pradyumna quoted earlier, but this time we're delivering pizza. Again, this is the consumer aspect of it, and I'll have a couple of slides on the enterprise aspect of it. But again, imagine the role of different entities in this transaction. So human asking for a pizza in a specified amount of time and for a price point, right? Few things that are kind of not layered within are implicit information. So your agent using an MCP knows all of your information, has access to your wallet, right? So this is agent kind of grounded into your own reality, goes out to open internet and looks out for who are the providers, right? And can do a lot of intelligent mapping. And that's why I feel, and again, this is my point of view, that NANDA is just not an index of different agents or businesses, but it can do intelligent mapping, almost matchmaking based on criteria, fetch the metadata of agents from private and public registries and bring back results, right? So once it kind of negotiates, so it helps with discovery, trust, and even transactions at some point of time. Once that established, then communication between agents to agent can happen in a peer-to-peer way, just like Pradyumna and Ayush were talking about, which can happen over A2A, ACP, or other agent-to-agent protocols. And then last thing, which is most important, is we have to, beyond just communication, we'll have to think about transactions, right? These transactions could be monetary, could be intelligence, could be services or whatnot, right? So 3 key value add that I take away from a lot of this NANDA conversation that I've attended in past and tried to deeply observe as well is solving the discovery problem, trust problem, and transaction problem, right? And discovery, as I mentioned, right, is beyond just listing of index and finding things or searching things. It is capability matching in a very intelligent way based on metadata, agent card, and agent facts that Pradyumna was mentioning. Think of something as almost like an agent resume, right? You could write whatever on your resume, but the interviews and the next set of conversation actually validate. And that is something that we've been working Microsoft a lot on. How do we validate agents before we kind of put them out into production? But that is kind of your design workflow, right? Trust gets established when the same verification and validation can happen on the fly, right? So if an agent says, I can do this, how do we know that is verified and validated, right? That could happen based on a behavioral proof of past transactions, right? Which can then create this point of view around kind of real-time, runtime validation of capabilities, not just kind of published sets of skills and capabilities. So again, NANDA can play a role there. And then on top of everything else is this economic activity of exchange of information, service, and intelligence, which can have an economic value as well. Lastly, one of the things that we deeply think about is trust at Microsoft as well. And as we build our agent SDKs, how does kind of trust gets layered? So if you look at the yellow, dark yellow kind of box on the left, that is how we've built agent in phase 1, right? Where there is a boss agent or kind of your primary agent, and it's grounded on tools and data that you have access to, hardwired, everything, right? Beyond that is your kind of the enterprise context. At any enterprise, there is kind of list of agents and kind of index of agents there as well, right? Some of these multi-agent architectures that are emerging are still very hardwired. You know, your boss agent knows which other agents it can leverage to get stuff done in the given context that it has. MCP servers, local, are also emerging as a way to extend the agent behavior. I can add multiple MCP servers without having to touch the agent code or agent instruction to extend the behavior of your kind of primary agent. And I believe, again, some private part of private registry would start to show up where, again, agent card-like things can happen, where within the enterprise context, you have agents that you have not hardwired, but you can discover, and then you can kind of attach to them and leverage them. All of this is happening in the trust boundary of an enterprise, for example. The moment you go out into the World Wide Web, it is untrusted agent web. It is hostile as well, right? Because there are nefarious goals as well. How do you can establish trust? And I feel that's where kind of NANDA plays a key role in establishing the discovery, the trust, and the kind of transaction boundaries. And this can happen through public registries, private registries, and at some point of time, even MCP servers could be discovered via the NANDA index. So that's kind of my rapid fire point of view on how I see NANDA play a role in this big agentic web. Professor.
Fantastic. Thank you, Ashish. I think those are some really good insights on how to start thinking about it. I apologize for your memories from childhood of being able to get a phone. But right now, we probably are bothered with how many calls you get and how many messages you get. So there's always something to worry about. Thank you very much. I'm going to bring up Rakesh Gohal to share his thoughts in a rapid fire presentation about the state of Agentic Web and what role NANDA is playing. And we strongly encourage you to follow Ashish as well as Rakesh Gohal on LinkedIn. I'm going to post their links in the chat. They're posting some really informative content, both of them with deep expertise, but also kind of sharing with us how the world of Agentic Web is evolving. Go ahead, Rakesh. I think you're on mute. Also, your screen is cut off.
Okay. How about now?
Yeah, it's good. Now it's good. Go ahead.
Good?
Yes.
Just 1 second. I'm making sure my mic is properly set. Oh, I don't know. It's not showing up my mic. What happened?
Everything sounds fine. So you're good.
It sounds good? Okay.
Yeah, it's good.
Okay, awesome.
Good.
So, yeah, all right. Just 1 second. And I want to make sure this is proper.
Rakesh, you only have less than 10 minutes, so please make sure.
Yeah. I'll make sure that I cover everything. All right. So, hi everyone. My name is Rakesh Gohal, and today we're gonna go further deep. I know a lot of presenter has covered a lot of other aspects of the things, and I'll also make sure that it resonates what the NANDA is trying to do. And just to give you a brief introduction about myself, I'm the founder of Geotech Inc., and I've been working in AI and cloud technologies for past 25 years. And I also co-authored a book called Agentic Artificial Intelligence. Okay. Now let's talk about the AI agents. Okay, so AI agents protocols, as you already know, they are universal translators, right? That helps you to talk to different AI agents. And the whole idea is they should be, who can develop that things, they should be able to talk to anybody else. Like think about your HTTP, right? Which lets your computer to connect to any web servers or anywhere in the world, as long as they have a websites, the domain name, and you can connect it, right? So without them, every AI agent speaks its own language, which is not good because we live in a world of diversity, and we need to make sure that we should be able to accommodate all kind of technologies and the things that we have, right? So I'm gonna go to the next slide. So as you can see, if you have a single agent, it's good for bounded tasks. It works for linear pipelines. And this is where the problem happens, right? It is inefficient, like when you are talking about specialized expertise across tasks. real-time collaborations if we need, or a multi-tool actions that we need to achieve. And this is where the whole problem lies within. So that's where the multi-agent systems comes into the picture. So we are going through a history and why we have landed up right now at NANDA, right? So just to give you some brief introductions about like that history. So on the multi-agent systems are like having a team of professionals, right? You are not relying on a single agent, but like you have a manager agents, and then it like gives a task to another agents, which could be a search, data analysis, or it could be even a cloud operations they want to perform. Okay, so what are the benefits? As you can see, they have a specialized expertise across the tasks. You don't need to have one agent loaded with everything, all kind of skills and everything. The other thing is real-time collaborations. You can have one meta agents can communicate with multiple different agents, as we saw, and the multi-tool actions, which is now you can automate it with your own specific agents, right? So, okay. And there are 6 design patterns which has been commonly used and practiced in the industries, and these are being implemented by individual frameworks, right? So frameworks are good, as we can see, but then, there is a big problem with the frameworks. Different AI frameworks couldn't talk to each other. Like so far, what we have seen, the LangGraph agents couldn't communicate with the AutoGen agents, and each system has its own rules and own languages, right? Some are Java, JavaScript, some are Python. So everybody builds their own agent their way, right? So there is a gap between these multi-agent systems, like they are confined into a cloud containers, or it could be on a cloud environments, or where they can talk to each other, but they can't talk to across the systems. So what this means? This means no cooperations between the different systems. Everything had to be a custom build, which we have been already doing that by building using those frameworks. And agents couldn't find each other automatically. So that is one of the other issues which NANDA is trying to address that. So no security, I mean, there were some security standards, but when those agents came out, they are still confined into one particular area. And you couldn't reuse these agents. Once you build it, you can just reuse those agents. So here is what I find very interesting. So some people are thinking about now we have a multiple protocols which are present in the industries now, and there could be looks like a potential war of protocols. But I think having different option is actually a good for everyone. So basically, just like we have a different internet protocols for different jobs, let's say an example of networking, we have one for networking, one for websites, and one for email, right? And we need different AI protocols for different tasks. And this is what we are seeing right now. So as we can see, late in 2024 and early 2025, new protocols emerged, and they actually started changing the face of AI itself, right? So the 2 important ones that we would like to just cover, and which has already been covered, is MCP and A2A. So MCP we saw in detail in the Nick's presentations, which was very much detailed. So I'm not going detail into the MCP aspect of it. I will go A2A, I can quickly cover in terms of what A2A is doing. So it handles how agents talk to other agents, as we know, and using the different frameworks, right? So AutoGen agents can talk to a LangChain agent. So this is where the A2A protocol comes into the pictures. So these protocols I see as not competing to each other, but they work together because MCP connects the agents to the tools, and the A2A connects agents to the other agents, right? So I don't see them as a competing one. But then again, there are multiple other protocols which are present, right? As you can say, they have a different kind of approach by individual protocols that has been created by various entities and organizations. And as you can see, this momentum towards open protocol is clear, like people are doing this. And while each company has their own reasons for doing this, but they are doing this for the sake of making that one party shouldn't control the whole ecosystem, right? That's the reason people are doing towards, and that's we're gonna see as a part of the process in NANDA. So I wanna go like what's further. As we can see, Sam Altman, he mentioned that it will be the year of agents. I'm not going in details there. But now here is something I would like to talk about based on what you just saw on the protocols, that you need to recognize the patterns. People are talking about network of agents, easy to access, and the real independence, right? They don't want to rely on one party or anything. And this is why much tech companies are actually investing in open protocols, because this is where the whole world is going towards. So, and there was one evidence we found that Windsurf was actually limited by the actions what Anthropic did, and they couldn't use the model and they couldn't perform. So they needed to scramble for another alternative solutions because they were relying on a single company. And this is what the message from Varun Mohan from Windsurf CEO that what just happened to them. So if we have open models and open protocols, this is where this could have not happened. This is what we imagine that going forward. Now, this brings us to NANDA, because we saw the centralization aspects and where it lands and why everybody is doing what they are doing with individual protocols. So network agents and decentralized AI from MIT, as we see, is created for the decentralized era. And NANDA takes three different, okay, one second, yeah. So NANDA takes three big challenges: the basic problems of building the decentralized AI, creating a new registry systems for specifically for the agents, right? So we had domain name, DNS for domain names and all. We had the numbers, as we saw in the early sessions, that we have been building this kind of registries from 1940s. Now we are again in 2025, and we are building the registries for agents because we live in a new era, new world. And building the secure frameworks, this is another aspect of it, while building together in the environments that we live, right? We need to build something decentralized so that everybody can participate and that everybody can have an eye on what is there, because open source solutions, many eyes can see it, and they can, if there are issues, they can be easily resolved instead of solutions which gets managed by individual company. So here is what excites me for NANDA. So it's not just the technology. I don't consider NANDA as a technology, but it's how it's being governed, right? This feels me like a Linux moment for AI. Just like a Linux made operating systems open and for everyone, it's a free, and NANDA could do the same thing for AI infrastructures. And we are moving forwards, like from world where we have a few big companies that we see, which is heavily concentrated or polarized by these big tech giants. We are talking about an AI capabilities where everybody can participate, innovate, including universities, startups, and business worldwide. Okay, so NANDA powers the ecosystems through four main abilities. As you can see, the discovery, which we saw in details how the examples were presented in the demo, the search capabilities, the authentication aspect, which is deed-based, which brings more authenticity in terms of what you can do, and the traces, the verifiable records of all the interactions which are happening against your agents. And it's built, I love these principles, like it's built on 5 different principles. The number one is the privacy, like everybody cares for it. right? And people want to protect their data. So privacy, using the way that it has been organized, it protects your data and no breaches. Verifiability, you can trust without blind faith, because you can go back to the records, the artifacts, right? The agent facts we were talking about. You can go to the agent facts, you can go to the traces and identify about all the actions which were done by a given agent. It has incentive models, which is a good stuff. The orchestrations, so combinations without central control, right? So you have a lightweight registries, and then you have individual elements, those like registries that are hosted by individual companies or on other marketplaces or anywhere. And the most important aspect, I feel, is the user experience, right? It's easy to use build a very good user experience, which is it's given to the people, let the developers build these things, right? NANDA provides a complete platform, right? It has the 4 layers. Number 1 is the infrastructure layers, which is the registries and databases that we are talking about. The protocols, the agent communication standards, as we are seeing, we have an adapters, which is sitting on top of the A2A protocol, so that it makes those communication and facilitates those communications. The third aspect is the developer tooling, and which is very important for any open source project, so that people can easily build these kind of applications. And the last one is we are not talking about any applications. We saw one of the application which Ramesh just built on the fly for Jessica. That was amazing, right? It's a real world application you can build and integrate, and you can personalize the way you want to personalize. So what's the bottom line after seeing everything else, right? Based on this presentation, what is the bottom line looks like? So here is the key insight that changes everything. And the key insight is the interoperability protocols are essential for AI agents to communicate smoothly across different systems. And without them, we are stuck with isolated islands of intelligence, right? So we don't want just an agent which is just relying, doing nothing in a corner, just helping to the organizations. But you can take this agent outside of your organizations, and it can be a part of a larger economy, the agentic economy that we are talking about. So we are moving from a single agents to a multi-agent systems or multi-agent teams, from a proprietary systems to an open protocols. This is where the whole industry is moving towards, and from centralized AI to a decentralized ecosystems where no single company controls everything. So, but here is my predictions. If I see everything else, I feel about the real revolution that we are seeing right now isn't just about the agent talking to each other. So that's not just talking aspect. It's not a communication aspect that is I'm focusing or seeing together. But what I see together in the coming future, it's about the agentic composability, right? So in a 5 years, businesses won't actually ask. In the next 5 years, they're not going to ask you which AI should we use. Business is not going to ask you, but they're going to ask you, how do we put together the right mix of specialized agents for a business? Or it could be a consumer aspect, the consumerizations that we are talking about today. It could be an any individuals. They can represent, they can create their own agents. So think about how we build websites with different components. It's the same thing we would like to do with the intelligence that we have, which is present in a multiple models, multiple industries, in a multiple organizations is there, right?
Excellent.
So the company.
Thank you.
Yeah. So that's all I think I want to say about NANDA. And the whole thing, if I would like to talk about the NANDA's, what it represents as the next step. So again, I will emphasize that not just connecting the agents, but actually creating the infrastructures for a truly decentralized AI internet. And you can
Thank you.
Yeah.
Thank you, Rakesh. That was a fantastic overview of how the ecosystem is going to play out. And we do want to mention that there's an amazing session coming up right after this, Rakesh, that will talk a lot about interoperability. And as you said, the roadmap, for how we're going to build this quilt in a post-AI world of the Agentic Web, it's a long one. When I mentioned 10-year roadmap, my students challenged me and they say this could be like a 3-year roadmap, the rate at which AI is moving. So, we will take bets on that, whether it's 3-year or 10-year. But again, communication is just a tiny part of it. We need different indexes, we need private ML, knowledge pricing, and we'll be talking about this on July 15th, which is our next big summit. In our own group over the last 10 years, of course, we have been working on this for more than 10 years, exactly developing these frameworks for network AI, first with AutoML, then with privacy-preserving machine learning, then with knowledge markets, and then more recently on decentralization. And in that spirit, we think there's a lot of good work that's already has happened in the Web3 world. If you just focus as a computer scientist, I'm very excited about the algorithms for immutable ledgers, algorithms for consensus, algorithms for publishing on chains, ability to analyze those chains, and so on. So in partnership with DAES, which we'll talk about in a second, we are launching a new RFP for the Web3 centric aspect of the index. There are non-Web3 players that are already building an index. We are working with them, but we want to spend a little bit of time thinking about just the Web3 aspect of the index. And we encourage you to engage with Project NANDA in those 3 phases, in the design, development, and deployment phase of NANDA. We have many newsletters, many writing groups that are coming up. So please stay with us and fasten your seatbelts. Next 45 minutes, we're going to hear about a lot of great projects, a lot of great collaborations on how this is all coming together. With that, I'll hand it over to Chris, Tricia, and Angela about building an index for Web3.
Thanks very much.
Thanks,
Thanks very much, Ramesh. Yeah, so just to briefly recap, so remaining now we have the Web3 component, and then after that we'll be probably running about 15 minutes over time. We've got a block from some of the projects that are presenting. So I'd like to hand that over to Tricia now. Thanks very much.
Thanks, Chris. All right. So as Ramesh was saying, we have a lot to work on. And I think in the chat, Cameron was like, I don't think we have 10 years or even 3 years. We've got 1 year, which is why we started collaborating with Ramesh's team at Project NANDA. And the next slide, you'll see that I'm Tricia Wong from the Decentralized AI Society. And so I think, Chris, are the slides up, or am I missing it on my side? You're getting the slides up, right? I'll just keep talking then. It's okay. So let me just tell you a bit about what the Decentralized AI Society is doing. We don't need the slides yet. And then you're going to hear some amazing speakers from our RFP that Ramesh was just talking about. And so I joined the Decentralized AI Society as the CEO about a month ago, 2 months ago, actually. And Decentralized AI Society is an industry association for AI innovators, enterprises, and institutions. And the whole point of this is to really make sure that we catalyze advanced AI adoption to benefit humanity. And when we talk about advanced AI adoption, we're talking about decentralization. We're also talking about privacy preserving options. We're talking about decentralized compute, everything that we all want in the Web3 world, so that we're calling advanced AI, since this decentralized AI isn't always known by everyone, except for in this community, it's a very familiar word. And so the reason why we needed to create this association is that because of exactly this discussion about speed of what Cameron from NEAR just mentioned and what Ramesh and his students are talking about, is that right now the tools that make AI safer, less costly, and transparent, they already exist, yet they're invisible outside of, if you're outside of Web3, you don't know that they're there. And it's exactly what the last speaker, Rakesh, just mentioned in the windsurf example, where when you're overly dependent on just one provider, you are at risk. And so what they were able to do, what Windsurf was able to do, is an example of going into open protocols. And so as you can see on the slide here, on our next slide, is the problem to solve, is that we believe this is a humongous issue to solve. And that's why a mature industry needs an industry association, is that there's this whole entire industry that's been happening, all this effort, all this energy that's under the umbrella of Web3, but oftentimes it's obscured under its own jargon, under the weight of communities not always collaborating together and moving fast enough with the Web2 world. And so that's why we've started this industry association. And the next slide explains that, we unite top builders into a cohesive force, educating people, and more importantly, really enterprises, helping enterprises understand how do we start building out our tech stack, so we're not just dependent on a few providers, but also we're looking at where in our tech stack should we be decentralizing and looking at the appropriate services that are very developed in the Web3 space, that are enterprise ready. And so this is why we are making sure that we develop this and take this, essentially building off of what Linux Foundation has done, organizations that have set this incredible precedence, where we believe this is what matters right now. And so one of our first collaborations is with Project NANDA on the Web3 quilt, exactly to accelerate, because we believe that by coming together, we can move way faster, as opposed to organizations working on their own, or organizations individually having to reach out to Web2 to figure out how do we make our registries interactable. So right now, I'll send the information for the RFP, but what we've done here is we did a call, and just within our deadline, it's at the end of the month, but we've already received so many great submissions. And so we thought for this event, it'd be really great to present a few of these kind of shining, bright stars that we're seeing, and some updates from members in the community that you're already probably very familiar with. And so this is our lineup. In the next slide, we have a few presenters, and we're actually going to start first. Oh, I see that we're going to have Phil actually come up. I actually have it, and it's like it's the wrong order, but we're going to start with Phil from Beacon. And I've asked each speaker to limit their talk to 4 minutes to give a quick update, and we will for sure hear from everyone in much more greater detail on the bigger event at MIT on July 15th. So Phil, why don't you take it away? And let's tell us what Beacon Protocol is doing. And what's I think incredible about what your contribution is, it's really complementary. You're talking about how a private data layer can really enforce the security, and security is a really big issue. We've had several people mention this in the chat. Chris, are you able to join? Let's see. I'm going to check on Phil in the chat. Let's see, you are a panelist, Phil, so you should be able to speak. Oh, it looks like you've been unpromoted. I'm going to promote you again. I don't know what happened. Let's see if that works now.
He should be on.
Hey everyone, how's it going? Am I there now?
Hey.
Yes, can you see me?
Yes.
All right, excellent, great. Thanks so much, everyone. I'm Phil McManus, CEO and co-founder of Beacon Protocol. One of the things that we're really focused on is being able to build out a data layer that allows private data to be used by AI models and agents. What's really interesting is we look at some of the challenges with data in general in Web 2. There's really no transparency of what happens with data after it's been collected. We rely heavily on very centralized, and even as we look at decentralized technologies, we rely very heavily on things like storage and compute to play critical roles as we look at controlling access to data. What's really interesting is there's sort of this, data comes together, things happen, and it gets used right in different places. That really needs to change as we look at how agents interact with data. Can I get the next slide, please? Thanks. So, this is an old version of the slide, so we're going to work with it. So one of the things that we have the ability to do with Beacon Protocol to bring to that Web3 quilt is the ability to have data provenance and understanding where data is going through its journey as it's being used by agents. Our approach relies on a modular AI stack to be able to maximize network scale. And what's really interesting about the way that it works, as I mentioned, is that it's storage and compute agnostic. So even as we think about things like data structures that need to be accessed, traditionally how that data is structured ends up going inside of a centralized or even decentralized database somewhere. The way we've built the protocol is to be able to actually define those data, to be able to find data structures in a way that's very flexible, doesn't reside in a centralized environment, but also makes metadata about the information that's available for discovery as we look at agent discovery as well. Next slide, please. What's really interesting about this is we really see this as being about private data rails that can be brought to the Web3 quilt. So one of the things that can happen that I think is one of the most important pieces is to enable private data collaboration. Data on its own is not really that valuable. It ends up being used and collaborated in a lot of different ways. We rely on people to be able to control that inside of Web 2. And as we look at Web3, we need to be able to have programmatic data collaboration. More importantly, it needs to be able to exist outside of just a specific storage place. And that's what's really able to give AI agents novel context about data. So that's one key piece of it, is being able to solve for that data attribution. Another piece that's really key about it is because we rely on end-to-end encryption of data, it plays a really important role in privacy and security. So one of the things is that we've been able to embed our SDK into MCP servers so that you can actually have security of data as it's moving through an MCP server. And one of the really interesting things that we're going to talk about next is what can start to happen is you move that capability into shared memory layers around agentic AI data collaboration, and being able to look at things like agent reputation. How do we know who we trust? Because I think one of the things that's really interesting is it's not scalable to spend all of our time and energy building gates around every piece of data that exists in the world and controlling what agents come in. We need to have data be able to move and be used across agents. Next slide, please. Thanks. So I'll give a quick example of how we see this playing out. The example I use here is, let's think about a travel agent booking a vacation for you. As you look at what happens, there's going to be that primary travel agent, but what's going to happen is it's going to tap in tasker agents like a flight agent, a hotel agent, or a restaurant agent. Not all of those agents need all of the information that's made available. And as you take a look at this, things like your passport only needs to be used by the agent that's booking the flight. The hotel agent doesn't need the passport, nor does the restaurant. There's also the ability to give programmability to things like agent reputation scores, types of agents, specific MCP servers that you want to be able to allow to decrypt and use and access that data. So that's another interesting thing that we can bring and support that in a way that doesn't require centralizing that anywhere and can be used to operate in an agent to an agent environment as we look at making private data safe across different agents. Next slide, please. So I'll stop there. I thought I threw my email on here. So my email is phil@beaconprotocol.com for anyone that wants to reach out to me to chat a little bit more about what we're doing and look at collaborating on the Web3 quilt. Thank you.
Thanks, Phil. And you actually kept it to 4 minutes. I really appreciate it.
Yes.
All right. So thinking about this, making it secure, I want to switch over to Hedera Hashgraph. We have Michael Kenner and we have Sham also, who will be speaking for Hedera. And I think you all will be talking about, giving us a really good peek about what's happening at OpenConv AI, Open Conversation AI. And this is a registry that's really talking about, I think, really connecting the first part of the whole point of this session today, which is we heard from Web 2, and thinking about how do we connect the web registries between Web 2 and Web 3. So take it away.
All right.
Thank you so much for the great intro, Trisha. Sorry, Sham, I wasn't sure if you're going to speak.
Go ahead, Michael.
I'm Michael Cantor. I'm the president of Hashgraph Online. And today, as Trisha alluded to you, I'm going to tell you about OpenConvey, a federated AI agent registry that's aligned with NANDA's vision of a Web3 quilt. Before I do that, let me tell you a little bit about Hashgraph Online. We develop open source standards, tools, and services for fully on-chain and decentralized agentic internet. These standards have already generated 28 million transactions in mainnet. Hashgraph Online and its standards, including OpenConvey, are governed by 10 leading organizations at Hedera. Additionally, our code will be contributed to the Linux Foundation through Hyro, and our standards are implemented on Hedera, a trusted DLT network that's backed by over 39 leading organizations like IBM, BitGo, and Aberdeen. So there's a lot of trust and governance behind OpenConvey. Let's go to the next slide. So we've created OpenConvey, which is an AI to AI communication standard with single-step implicit monetization and a decentralized registry for AI agents, robots, MCP servers, and humans. Any entity really can use OpenConvey. Profiles from OpenConvey are stored on chain with inbound topics that you can talk to and make requests. And you have outbound topics, so you can see a history of all the requests that agents have ever done. Additionally, all the messages that entities make through OpenConvey are stored immediately on chain on the Hedera consensus service with optional encryption. We've seen incredible success at Hashgraph Online. We've had with 7,000 weekly NPM downloads from our standards SDK, 300,000 daily CDN requests through HCS1 file inscriptions. And recently we co-hosted a Hedera X AI event, which had over 500,000 views across all streams and 12,000 transactions during that event from our testnet version of OpenConvey. Let's go to the next slide. But what we're seeing in the future, and what we've been alluding to throughout this entire presentation with NANDA, is weaving isolated registries, even ones like HCS10, into one shared fabric. We see registry brokers as DNS for AI agents, and these are basically nodes that anyone can run, anyone in the world, and we want a lot of people to run these so that you prevent any sort of centralization. These brokers would have capability-based discovery across all these different registries, and these registries would be bi-directional links between Web 2 and Web 3 registries. So you can have a registry on HTTP, like NANDA's example. You can have a registry on a smart contract. You can have a registry in HCS10, and you can combine them all together, have federated discovery and cross-registry search and routing. And the best part is these registries won't have to change a thing because brokers would have their own adapters that we were talking about earlier that we can also leverage that NANDA has built out. So you can essentially just plug in this adapter into a registry broker to enable additional registries. All of this would be immutable with trust attestations and verifications stored on the Hedera consensus service. And you share what you want to share, but you can always replay it through ZK proofs. Let's go to the next slide. So how does this all work? The architecture, again, it all sits behind trust and the Hedera consensus service. We have an HCS10 registry. We already have a formalized standard as a standards body, and we would extend that standard with a new federate registry operation, which will allow access and configuration to talk to all these different kinds of registries. And you'd have a bunch of brokers that essentially implement these adapters and enable an end user to talk to a registry broker to enable AI to AI communication across Web 2, Web 3, and any other ecosystem. Let's jump into the last slide here for next steps. What we see going forward to make this a reality is creating these new open source standards, which we'd love to work with NANDA on implementing, which means registry brokers, MCP, and adapter registries that would all be compatible with NANDA's core. We'd partner with Web3 and Web2 companies like all of you guys to create dedicated adapters that work inside this registry broker ecosystem. And we'd have Hashgraph Online members as initial node runners for registry brokers, but also NANDA and universities and anyone else that really wants to participate. And finally, we'd close off with a hackathon to see an initial adoption of partnering again with NANDA and anyone else that would like to be a part of this shared vision. Again, thank you guys, and I look forward to collaborating with you in the future. If you'd like to reach out, you can find us on X at Hashgraph Online, or you can send me an email at michael@hashgraph.online. Thank you.
Thanks so much, Michael. Next up, we're going to have Raghubala from Synergetics. And I think what's going to be exciting about the perspective we're going to hear from Synergetics is what we were just talking about earlier with Rakesh, is that the future is going to be more in modularity. It's not going to be about which AI agent or which registry, but you're going to figure out what is the best set of tools that we're going to put together. So why don't we have Raghubala, are you on?
Yes, I'm on. Yeah. Thank
Okay,
you
great.
for
There
having
you
me,
are. Yes.
Tricia.
You have
Hi,
4
everyone.
minutes.
Thank you.
Please start.
Hi, everyone. So basically, this forum has a title of Consumerization of Agentic AI. So in that realm, actually, it's important to recognize that we actually have something called an agent economy going on currently. And that economy itself is made up of, I would say, at least 3 different constituencies as shown in the picture on the left. So we have enterprises on one side who are deploying AI agents, and within them, there are different personas and roles that are sort of coming about. And then we have this whole area of creators and consumers who are consuming agents. and people who are creating models and all sorts of other things in and around agents, everything from voice to chat technologies and so on and so forth. And then we have a community which is also coming about, and this community can extend from anything from investors to even if you want to crowdsource your testing of your models, there are folks who will join this economy to do that. So in order to empower this economy, we have developed a set of tools in our platform called AgentWorks, which you have the tool to train an agent, a tool to test an agent, a tool to certify that the agent can be placed in a marketplace that I'm going to show you, and then a workflow tool to set up the workflow for agents, as well as a deployment tool to deploy it on any type of cloud environment, AWS, Azure, GCP, NVIDIA Cloud, and whatnot. At the end of this process, you get an agent, which is an autonomous agent. And unlike a lot of the agents out there, this autonomous agent has an agent ID, which is persistent, and it's registered in an agent registry. And that ID is held in a wallet. Now, this agent is autonomous. It's got an ID just like you and me. It can even walk, talk, and do various things. It can reside in the physical world or in the virtual world. So now it can connect to any website. So for those who are familiar with Web3, who are familiar with Wallet Connect, we have something called Agent Connect, where you can present your ID and then connect to those websites. Also, I want to back up and also state that this agent ID process, in order to get registered in the registry, we have a KYA, which is Know Your Agent. So only good actors can get into the registry in the first place. And then finally, there's Agent Talk, which is a superset of A2A from Google that enables agent-to-agent communication. And that agent-to-agent communication is a structured communication, not only unstructured, but there are different vocabularies that one can extend in that particular protocol. And finally, agents can be placed in a marketplace, just like you have a marketplace for products in Amazon or apps in Apple. You have a marketplace of agents that you can rent and so on. Now, having said that, let me connect the dots with our work at NANDA. So can I go to the next slide, please? Okay, so we were recently approached by a public company wanting to create an agent-to-merchant communication structure that they can easily deploy at any particular online merchant. So, for example, merchants that are on Shopify and things like that. So they came to us and said, how do we do that? And we gave them two ideas. One is, if the merchant already has an MCP infrastructure, then we can have our decentralized autonomous agent connect with that merchant using MCP. But if they already have a merchant infrastructure, then we can use agent talk protocol in order for the two agents to communicate. Our merchant agent, the merchant agent with our decentralized autonomous agent to conduct e-commerce. If you go forward, next slide. So I'm going to show you a very, very quick video, if you can play it. I don't know if the sound will come through, but I'll narrate it. So in this particular video, these agents, there are two agents that will come about. And these two agents are basically trying to do commerce. There's no sound here. So one is a buyer agent and one is a seller agent. And the buyer agent is Emma and seller agent is Jake. And this would be a potential merchant agent and a digital twin of a consumer, or it can be even a business representative. And we leverage the agent talk protocol. And in this case, this particular buyer agent is trying to buy sunglasses from this seller agent. And this is all done. Actually, the code works and using the protocol. And once they negotiate a price, then there is a transaction that happens under the hood. And this could this will leverage the wallets of both these agents, as well as the currency, the mode of payment will be both Web 2 and Web 3 compatible, so that those who are from the Web 2 world feel included in this process. So we can move that forward. We can just forward the video a little bit. Actually, at the end of the video, the agent that buys the sunglasses wears the sunglasses. Okay, now what we also recognize is that a lot of the, players in this space, the enterprises have already made some investments in tools like LangChain, Crew AI, and others. And so what we set out to do was not to alienate those folks, is to build an ID creator, which is one of the projects that we are proposing for this particular initiative, so that this ID creator can bring in those agents and give them the same capabilities that we natively have when building an agent using Synergetics, such as the persistent ID, the registry entry, an agent name, which is a .twin name, TLD that we own, as well as provided with a wallet and the ability to communicate and so on. So this creates interoperability between any agent built on any of these platforms. And we are adding more as we speak, so that the agent ecosystem is now has a common substrate through which they can all communicate with one another. Next slide, please.
Can you wrap up now and with this slide in 5 seconds?
Yeah, I'm going to finish up.
Thank you.
So the final part is the protocol builder. So the protocol builder is basically when we patented this protocol, the first level is for agent-to-agent authorization, authentication. The second part is vocabulary. So we saw an e-commerce example. So we can add other sort of vocabularies for other types of interactions. And we are also building a protocol builder as part of this RFP. So thank you for your time.
Thank you so much, Raghu.
Thank you.
Definitely, we can see how this modularity is going to be so important, and it's great to get a peek at this. The next speaker is going to be Christian Killer from Akros. And, unfortunately, we're not here to hear about what companies are doing. So you'll have to, if you aren't familiar with what Akros is doing, please look them up separately. It's some really cutting edge stuff that's happening with, actually edge phone compute. But what Christian is going to present today is how their confidential and distributed compute network can actually power the NANDA registry. So why don't you take it away, Christian?
Thank you so much for the warm intro. Yes, exactly. So I've been listening to all the talks, and to be honest, like lots of the challenges really sounded like what we were tackling for the last 3 years, such as being highly mobile, being privacy oriented, being safety critical up to trillions of devices. So it really sounds very aligned with NANDA. And that's why we also submitted to the RFP, of course. But let's dive right in. Don't worry, I'm not going to take longer than 4 minutes. So next slide,
Thank
please.
you.
So as you can see on this slide right here, we try to embed or sort of marry together the concepts that NANDA outlined, implemented in demos and also in papers, because we can offer compute, storage, and routing. So how can we embed it in this overall architecture, and then also power the registry quilt, such as having a lean registry in the end, or agent facts layer, and then sort of embed it and in all of this communication. Next slide, please. Why phones? So this is always important to outline why we actually do it. And as you can feel also during these 3 hours right now, it's such a natural choice, because if you want to tackle the centralized cloud providers, we sort of have to provide an alternative that is not built on traditional server hardware, because phones are decentralized by design. They're scalable by design because we have so many of them worldwide. Their hardware is really good. It can compete in terms of performance per watt. It can compete in terms of processing power. And then it's also verifiable by design, because we have very secure chips in there that we can use to actually bootstrap a trusted execution environment, which then leads to the fourth point, which is that it's confidential by design. So this is sort of our backbone. We have 85,000 phones right now onboarded already. Next slide, please. On this flow here, we just wanted to exemplify how the Akros processor, which in this case is a single phone that is locked down and only running the Akros processor software, so it's also bootstrapping a trusted execution environment, how it is being used to process a query, for example. This is very simple. So it comes from the user, goes to the processor, and then also can return a result, of course. But this can also be embedded in much more complex interactions, of course. It can also run LLM inference, etc. So also depending on the science of the size of the model, this works pretty well. And then also for verification, sorry, just one more. For the verification, we can actually use it to verify, for example, agent facts. And everything is, of course, backed up by a chain that assures consensus. Next slide, please. So, of course, this implementation roadmap, I would redraft it after today's talks, but I think overall the outline is pretty clear. So we would have a standardized protocol to sort of enable interaction with different registries and also have a lean registry ourselves on Accursed, then do this as a pilot program and then use it also to optimize performance. So I think these three things are very clear and a natural match in my opinion. And then, of course, since it's research, it never ends, and it also never ends with regulatory compliance and growth at the end. And if this comes to fruition, we of course need to decentralize it in the end. So it's 9 seconds until 4 minutes. Thank you for the attention and have a nice day.
Thank you, Christian. You gave us 9 seconds back. So in this next talk, we're going to actually go to, when we talk about AI agents and registries, and we're talking about why it's so important to have security, here's a whole critical sector where we're going to talk about space and talk about like a really critical sector where how is this going to work? And this is why we need to really think about interoperability, because we really don't want to just depend on one point of failure. So Sharath, why don't you take it away with 4 minutes on the clock starting now?
Hi, everyone. This is Sharath Chandra. I'm here to present my research and what I've discovered through looking through the ecosystem of space and the infrastructure for space. What I discovered in the last year of research in my quest to build a compliance solution for space and my obsessions for patterns. I discovered that, next slide, please. I discovered that space has the fundamental Byzantine consensus pattern. It covers multiple jurisdictions, both domestic and international. And in my observation, as Jessica mentioned before, I realized that frequency management is one of the major conflicting authorities across just the domestic agencies and not even international. What I'm proposing in this particular instance is, next slide, please, is that NANDA Quilt, the registry, the tools, seems like a perfect test bed to address the issue of infrastructure in space where satellites act as autonomous agents with DIDs, private registries. The regulators are nodes, and the option for the MCP architecture to discover other tools and forms across agencies. And what I'd like to do is to continue this research with NANDA and the team in order to find a perfect solution which could potentially allow for us to understand patterns within these regulations and contribute towards other regulated domains. Thank you.
Thank you, Sharath. Well, this is something we're definitely going to have to figure out if we work when we go into the world, as we go into the world of a million, a billion, trillion agents, is that space will definitely have to be considered. So next we have Cameron from NEAR. I think we're all very familiar with NEAR's work. Cameron, why don't you give us an update on the work that you're doing? And in particular, I think for NEAR AI, it's very important as you are the platform for the future, future for Web3 AI. So what's the update on the latest that you've done? Do we have Cameron here? Oh, Cameron's not on screen. I think I'm going to ask you to rejoin as a panelist. I think you were kicked off.
Great. Hey, everybody. How's it
There
going?
you are. Hey, Cameron.
Good to see everybody.
Yay. I'm going to start the 4 minutes now.
Beautiful. So, hey, everybody. My name is Cameron Dennis. I've been building in this decentralized AI space for the last about 1.5 years. For those who don't know NEAR, it was started back in 2018 after one of the co-founders wrote Attention is All You Need. This is the Transformer paper, the T in ChatGPT, and built NEAR primarily to ensure that superintelligence does not fall in the hands of a single company. In order to do that, we first need to build a protocol that can actually maintain the scale needed to facilitate agentic commerce and AI. Second thing is we need to make sure that all of these different blockchains that exist can easily interact with each other, so users don't have to care what blockchain they're using. They just use apps that, well, fulfill the mission of user-owned AI. And then lastly, this like sort of third important part is making sure that this whole decentralized AI stack, a tiny piece of it is laid out here, is an ecosystem. So it's kind of, we share a very similar goal with NANDA and sort of building this quilt. We recognize that there's no way that one company is going to be able to build all of this. This is many different companies, as you can kind of see here. And we're chipping away at this pretty quickly. And so when I had mentioned earlier that like we don't have 5 years, we don't have 2 years, in our opinion. We have about 8 months to 16 months. And so in order to facilitate this, it first starts with all the compute. I don't know if everyone here should know, the new Blackwell series NVIDIA GPUs, H100s, H200s, and B100s will all have this trusted enclave in it, a TEE on the GPU, to facilitate verifiable AI hosting and training. And so we've been sort of at the cutting edge of this, not formally in collaboration with NVIDIA, but working closely to essentially drive demand for this new GPU TEE driver. And so we built something called the private ML SDK. Everyone's able to use it, totally open source, to facilitate private agent hosting. So we did this about a year ago. And since we last met, I think I gave a talk in about April, we've made a lot of progress. And so first off, we introduced this concept called shade agents. I don't know if you can see, I don't control the slides here, but okay, 2 more minutes. So shade agents are essentially agents that are verified on chain and have the option to be completely confidential. And so there's a slide somewhere else in this deck, if you're interested in looking at it later, unpacking that. You could also just go to shade agents on the NEAR AI docs and dive into that. The whole point here is you need to trust the agents that you're using. And the best way to do so is verifying the actual code that is running them on chain. And so we have a few amazing examples of this. They work in production today. Highly recommend looking that up. Second thing is we're enabled TEE agent hosting with Follow Network. Follow Network is a very close partner of ours that has been operating this TEE on the CPU side space for about 5 years. And so they have access to a lot of hardware and a lot of subject matter expertise to facilitate confidential and verifiable agent hosting. So that's a big part of the stack. If we're trying to ensure that AI is truly owned by the user, it needs to be verifiable. Next thing is, in order to get agents money, you're going to need to on-ramp fiat to crypto somehow. And so we're leveraging Coinbase's USDC on-ramp to on-ramp really any asset from any chain to any agent. And so there's an entire demo about that. Again, these are all separate companies that are building, and I work very closely with all of them to, again, sort of like, use the NANDA example, like build this quilt. And so we built that. It works. No KYC up to $500. It's pretty amazing. Next up is security. So if you want your agent to communicate with another agent, I want to make sure your agent isn't going to leak my private keys, or you're not going to disobey the privacy policies that it's interacting with. And so we do have an agent security framework built with a partner of ours called Vigil. And we're actually able to verify and test code even if it's confidential running inside of TEs. Got 10 seconds left, but TLDR implemented Google A2A cards, adding a huge liquidity, like adding a liquidity layer for all agents to transact. And most importantly, building an agent hosting network that is completely framework agnostic. And so doesn't matter if your agent's built on Crew AI or OpenAI or whatever, they will be able to communicate with each other. About,
Thank you, Cameron.
Yeah, that's a lot. So hopefully didn't lose anyone.
No, I think your proposal is very similar in line with some of the other ones we've heard today, which is very holistic. And it's really great to see that you're thinking about payments and really holistically from the user perspective, which is, what you've all been doing. So thank you. Up next, we have Patrick Bois, that actually is the last presentation from the ArtaNet project. And Patrick is going to explain how determined agent and identifiers can ensure this kind of synchronization that we're looking for across registries. So he provides a really good example of the kind of RFPs that we're looking for. And again, as a reminder, we have until June 30th. Today is just a peek. And now, Patrick, you're going to take it away with 4 minutes on the clock. Are
Awesome.
you ready?
Thank you.
Hey,
Yep, I'm right
I hear your
here.
voice.
Hey, how's it
Hello.
going, everybody? I'm Pat, and I'm a member of the ArtaNet project. So we're a collective of researchers and engineers from around the world who are mission is essentially to democratize intelligence. Now, we built a platform and a set of tools that allows agents to connect, communicate, collaborate. And I'm going to walk you through how we synchronize registries on multiple indexes, multiple blockchains, as well as Web 2 infrastructure. So next slide. So our primary goal with the ArtaNet project is essentially bring together fragmented solutions. So a fragmented ecosystem has essentially been created when it comes to agentic communication, and we're focused on creating a routing layer that allows messages to be sent back and forth from Web3 agents, Web2 agents, and all manner of agentic platforms. So next slide. So what are some of the core issues that the agentic communication is essentially facing? So some of them are barriers to discovery or limiting collaboration. A lack of standards is severely hampering the development of the ecosystem, as well as rapidly emerging protocols are creating fractured networks. And larger players are incentivized to create walled gardens, so essentially silos of agents that work really well within their own ecosystems, but maybe don't necessarily collaborate with other agentic systems as well. Okay, next slide. Okay, so in order to synchronize agents from across our kind of ecosystem, across our network, well, we determined pretty early on that deterministic agent identifiers would make that process a lot easier, as well as a lot kind of faster and easier to essentially link agents across networks, as well as their agentic details and agentic facts. So in the case of the ArtaNet, we came up with DADE, which is a deterministic agent identifier. And this is composed of a core, essentially, registration that is consistent amongst most of these emerging agentic protocols. So like agent facts or agent cards and some of the other emerging communication protocols or listening protocols for agents. And we take those core details, we hash those, and then we hash them with a registrant identifier. And this identifier could be, a user's wallet or just a unique username, a unique ID related to the user's account. And we hash that again to create a DADE. And this allows us to synchronize decentralized registries because of the fact that agent identifiers are deterministic. And that enables registries, clients from across the ecosystem to derive the same identifier for any given agent because of the fact that we're limiting the core fields of the registration to these aspects. Okay, next slide. Okay, so this is the last slide here. This is essentially the rationale for the goal of DADES, and that's to ensure that registries and clients can derive the same identifier. Our constructions use SHA-256, which is highly available and efficient, and also has strong inbuilt collision resistance. The deterministic nature of these IDs make them easily replicable, make them easier to replicate across systems. Sorry, tongue-tied. It also facilitates deduplication and non-repudiation amongst agentic ecosystems. Initially, we intentionally decoupled identification from authentication to allow individual registries the opportunity to endorse agents without a central authority. DADES are also naturally expandable, allowing them to become the root hash for composable namespacing or used as a standard and compliant method for generating DIDs, so decentralized IDs, that the entire community can align to. And that's it. That's me for the RTNet
Thank you
project.
so
Thanks,
much, Patrick. This is a really great overview, and this is really cool that this is a, someone can turn off their audio. I don't know who else we can see hear your car sounds, but this is a really good. Someone just muted me. This is a really good idea, good take on. It's really cool to see, researchers coming together internationally to work on this in your collective. And so with that, I'm going to have Chris put up the last slide, which really gives an overview of the timeline for how you can participate in the RFP. Again, this is a really historical moment. I love that Jessica, former FCC chair, gave us kind of this history of situating us where we are historically. Is that we are in this kind of moment where these are like the early days of, that's akin to when the internet was being built, or early, when the telephone numbering system, was started. We're in such a moment right now. And as Cameron also has mentioned several times, is that we don't have years, we have 8 months. From our perspective, we agree with that timeline. And this is why we started this industry association, is that we think that, we highly believe that collaboration is key. And as you can see from even the slight peak of responses within, just a week and a half, we got all these proposals, is that's very clear that not one company is going to offer this solution. It's going to require all of us to come together. And that's why we're going to post a link again for the July 15th event, is for you to attend and also to participate in the community, and to find ways to really contribute so that we can move much more quickly, so that we don't lose this window of time. And so I'm excited, and the rest of the team is excited to see more presentations. We'll be building out a steering committee who will be evaluating these solutions. And then on July 15th, we'll be selecting, you'll be getting a notice of presenters. You'll hear from some of the presenters that were here today, and we'll present again. But at that date will be key, because we're going to figure out how we're going to actually move forward to build the next step. And then on September 8th, we come together for the actual final presentation of a solution that we've come together as working groups. And even if you're not selected, we still want you to participate. So with that, I'll hand it over back to Chris. Thank you so much. And I'm going to post my information so that we can stay in touch and ask any questions.
Thanks very much, Tricia, and thanks to all the presenters. And just to reiterate, the on screen at the moment, that June 30th, that's the deadline you're working towards, Tricia, right? And I know we have an earlier date listed on the website, but we do need to change, but pay attention to this one. Good. And so we're going to move on quickly to, we've got a number of projects that have been working with NANDA, with A2A, with MCP, to help illustrate kind of how some of this is being taken into action, into the real world. We're all trying to build on this moving train, and these are a number of them. So we will start with Rob with Polystack. And speakers, you can unmute yourself.
Can you hear me?
Yep.
Oh, perfect. Hey everyone, I'm Rob. I'm a current MIT student and one of the founders of Polystack. I spent many years as a market researcher and saw a lot of challenges with building and analyzing surveys and forms where it could take up to days or weeks to get done, when a lot of this should be much easier. So with Polystack, we're helping to deliver professional grade surveys and forms in seconds. We've already developed a robust backend with proprietary models and are going to be releasing agentic features all summer. One of those being, it should be so easy to take the context from an existing chat to launch a survey. So we've integrated directly to make it so that you can use an MCP host to launch a survey, have the link sent back to you to then send around. We're also rolling out today a feature to be able to import directly into a text box and launch a survey. So if you have a long conversation in ChatGPT, copy and paste that in and instantly have a survey ready to go. We'll be rolling out more things around analysis throughout the summer. We're already serving a handful of MIT and Harvard startups and looking to expand right now. For the moment, we're giving it away for free, especially to NANDA users. So we'd love to have you guys on board. And thanks for the time. Kept it under a minute.
Thanks very much, Rob. And moving on to Biddy. You can unmute yourself, Biddy.
Yes, can you hear me?
Yep.
So hi everyone, I'm Vivi. I'm one of the co-founders of Agentic alongside Miles and Gary, who are also on the call. And we are essentially building a security layer for multi-agent systems, specifically the agent-to-agent protocol. And we are advised by Chris Clouds. So as we know, the pace of rapid AI agent deployment is accelerating and it's outpacing the development of security tooling to protect these systems. And so we're essentially building a pre-deployment developer tool, which is a code-based scanner backed by a quantitative benchmark that we're working on that maps communication between agents, tools, protocols, as well as MCP servers, detects and patches vulnerabilities, quantifies system security, and delivers educational resources to help teams build safer systems. Our project first aims to establish a robust benchmark in tandem with OWASP's initiative, as well as NANDA's ANS security blueprint. And then our project aims to complement and operationalize these frameworks directly within the code generation tools that often introduce such vulnerabilities.
And basically, by doing so, we hope to generate novel data on agentic patching as well, potentially surface edge case behaviors, and also potentially contribute to the development of a more robust and security-aware benchmark and use case.
Awesome, thank you.
And we've seen, oh, sorry, Miles.
Go ahead, go ahead.
We've seen how code generation tools are frequently used to create simple agentic systems with few safeguards. However, as those systems scale into usable products, the vulnerabilities created in early development become very consequential. And as student developers, we're exploring this space from the ground up, and we'd love to hear your thoughts. Feel free to connect, and I think we'll send a form in the chat as well if you want to connect further. So thank you guys.
Yeah, I'll be sending that form over. Thank you so much.
Thank you very much. Next up, we have Todd with BioShift.
Hi, my name is Chad Curl. I'm one of the co-founders of BioShift. We're building a scientific labor marketplace to help laid-off lab workers and labs affected by federal funding cuts to continue to do science, keep talent here, and prevent brain drain. For the agentic layer, we're looking to onboard these scientists into the labs quickly. So we're looking to use agents to standardize the standard operating procedures of these labs, make sure that the experiments are done within spec, on time, and they can access not only the talent, but the resources, lab space, tools. They can do reservations via agents. If that particular lab does not have that particular tool needed, they can reserve space across the street, across town, in order to get those jobs done. The example workflow is here. So a discovery agent would go ahead and find the metadata, find the institutional documents relevant to the lab work, create an output, do the compliance checklist, get everything done, reserve any equipment that needs to be done, give a project outline, and then help the scientists get everything done on time, on budget, and quickly.
Next up, we have launch compliant. Is launch compliant on the call? Okay, we'll move on to Iris. I'm just promoting you, Lauren. Okay, you should be good to go now, Lauren.
Hi everyone, I am Rishabh from AI Blockchain, stepping in for Iris founder Lauren Roth, who is catching up a flight between time zones. Today isn't about another app, it's about retiring the social feed. So with Iris CI we consider as a privacy-first networking operating system where your personal agent lives on a private carbon neutral blockchain. We run with AI blockchain company. Every note you speak is sealed with homomorphic encryption and zero knowledge proofs raised across MCP, A2A, and NANDA to find exactly 3 conversations that move your mission forward without exposing a single byte. So you ask who can untangle your term sheet, Iris surfaces Christine, books coffee, and pushes the context while you stay fully present. We are enjoying real birds stranded at planetary scale. Let's like build it out. So that's all about it. Thank you.
All right. What comes next?
Thank you.
What do we do?
We've got someone to mute themselves there. Yeah, Pat.
Hey, how's it going again?
Good.
Pat from the ArtNet project. So here we're just kind of detailing a little bit about how the ArtNet project does relay work. So it's essentially a switchboard that uses our internal agent name service. So this is kind of the agent name service is an emerging kind of standard coming out of OWASP. But yeah, we utilize that to request registrations for the user application and then connect to the agent ourselves and forward requests back to the user. So it essentially acts as a switchboard for agentic systems. But yep, and that's it. And feel free to check us out at the ArtNet project or artnet.io.
Cool. Thanks very much.
All right, hello folks. Thank you so much for waiting to near the very end of this presentation. So we're a blockchain first company. We're building on the virtuals protocol using the game framework and the agent commerce protocol. All of this is kind of insular to the base blockchain. But we're interested in autonomous capital deployment. And what we're really excited about is this is an amazing capital formation opportunity for AI startups. You used to have to split your time between building something and begging for money from VCs, but now you can build it and then launch it on one of these platforms like Believe or Virtuals, and then you can get money in a more crowdfunding sense. So first, our agent will only explain investment products and risks. Later, it will manage funds across these different blockchain vaults for users. Vaults are similar to hedge funds. And then frankly, if you're serious about agentic AI being able to transact without being shut down, you have no choice but to use blockchain solutions because the current decentralized payment networks are just really slow and they have very bad time to settlement. So if you're interested in automated investing, please talk to me. I'll put my LinkedIn in the chat. Thank you.
Thanks very much. And last one, Eric, yeah, bring it home for us.
Sure. Thanks very much. And again, thank you all for staying. I'm Eric Jesperson, co-founder and platform architect at MyLife. We're a nonprofit offering free human-centered digital legacy platform. We empower individuals to preserve for posterity their memories, ideas, and values, and using consent-first agents to vitally reflect your ethos, engage based on your intent, and operate entirely within your natural language consents. And we, like many you've seen, do indeed leverage a decentralized assistive intelligence with MCP currently in A2A to onboard external agents. We aim to find initially those through the NANDA registry, and these can be incorporated into our framework and into our ecosystem. Members can, choose beyond their defaults to assign. This slide here is quite complicated, but I just wanted to give an example of how we're using it currently. So this use case will work as soon as we get Stony involved. But the idea is that we understand that we're in a larger ecosystem. And so in a case where, let's say, a MyLife avatar doesn't have access to your current interests, we would engage with the NANDA registry to find your personal agent that you have created there. If it has your current interests, we would, in this case, fly fishing, we would incorporate that based on a number of other consents, whether we save it to our database, et cetera, is an entire question. But I'm really just excited because we know that NANDA is building a decentralized nervous system for synthetic intelligence. And this is the ecosystem that MyLife has anticipated and actively engineered towards. And we're fully aligned with our mission here of human-centered digital legacy, dignity, and ethical AI. So we've been a part of NANDA from the beginning, and we will continue to be a part of NANDA incorporating these functionalities. We're currently live in alpha, and if any of this resonates with you, please come build with us. You can find me on LinkedIn. I'm Eric Jesperson. Thank you very much. If you don't see MyLife in anywhere on the profile, you've got the wrong Eric Jesperson in LinkedIn. Thanks so much, Chris. This has been a fantastic summit.
Perfect. Thanks very much, Eric. Really appreciate it. Yeah. And so Just to close out briefly, I'll leave this screen leave this slide on screen. Different ways you can engage with NANDA. On the design part, we've got the writing groups that Ramesh mentioned, and there's a link for that at the bottom. The onboarding steps for NANDA writing group. There's the general R&D effort, the working groups that we have. In particular, the Edge AI is a lot of stress on that one at the moment. And then we've got the development community, a design partnership there that's gone into action to help on the engineering front. We're always looking for additional engineers to help on the development front, and that could be individuals. It can be if you're with a larger enterprise, then we're looking to engage. Maybe you can help provide engineers for a certain phase of the project. On the deployment piece, we're really looking to get Project NANDA out into action. One of those efforts is to help with simulation. So we're looking for kind of some serious partnerships there with industry to do simulation. So what that means is setting up lots of different entries on the index that can work together to simulate a particular piece of industry. So we could use that for a case study. You can sign up on the form here, registering different interests, and we'll be in touch with you, aligning with those interests, and then also that'll get you onto the regular newsletter. So thanks, and I'll hand you back to Ramesh.
Fantastic. Thank you, Chris. We thank you for joining today's session. We'll see you on July 1st for our next online event, and then on July 14th and 15th in person at MIT. With that, we're going to say bye to the recording, but we encourage everybody to stay on for informal conversation for the next 15 minutes.